Hey everyone. Very good evening. Welcome to each and everyone. Namaskaram, welcome, vanakkam, suswagatam. This is your Baba HSP. Just do let me know in the chat section, my dear friends. Am I audible and visible? Can you hear me? Can you see me? Your Avengers team and Baba HSP. If yes, everyone, am I audible and visible? Just to let me know, my dear friends. If you can hear me, can see me perfectly, then I want to see green signal. And kids, really I missed you a lot. Today we will see this awesome chapter, your hydrocarbon, alkanes. I will let you know from the scratch each and everything with the proper sequence what I'm going to teach, what portion I'm going to cover, definitely each and everything, minute points, my dear friends, I will tell you in a decent way, each and everything, the mechanism wherever it is required, each and every single point where you need to cram, I will tell you the tricks. Baba will give you tricks. The proper sequence of NCERT I am going to follow. Let me tell you, my dear friends, if you can hear me, can see me, I am going to tell you, I will follow proper sequence of NCERT. What I will follow? Let me tell you, kids. First point, I will follow definitely the sequence of NCERT. What I am talking about, kids? Baba is going to follow sequence of NCERT. Sequence, exactly the sequence of what? Your NCERT. Sequence of NCERT says first the preparation, then the physical, and then the chemical properties. P, C. What do you mean by PPC? The preparation of alkanes, the physical properties, most important physical properties, and then the chemical reactions, they are going to be the chemical properties. I will deal with PPC. And in this PPC, the preparation, there are three types of preparations given in NCERT. One, the hydrogenation, second from alkyl halide, and third from RCOH. I will tell you in detail the three preparations, but before I move ahead, kids, the preparation that is hydrogenation, and then from RX, and then from RCOOH. This further RX is divided in two parts, part 1 that and part 2 Wurtz reaction. Here also two parts, soda lime and then Kolbe, soda lime and Kolbe. I will tell you each and everything. It's soda lime and then Kolbe. Here the Wurtz reaction and the LiAlH4. I will tell you each and everything. Then chemical properties. But before that, before I start, kids, I welcome back to each and every my dearest and most intelligent students, all the future doctors and the engineers. Can you properly hear me? Can you properly see me, kids? First of all, do let me know. Am I audible and visible? Yes. Are you ready with full on Josh? If you are ready with full on Josh, full on energy, then I want to see some fire. If you can hear me, I want to form a bond. Today you will see Baba HSP's new magical change that you will feel that I'm totally connected with you. You are just sitting in front of me. You will feel today that. How many of you want that? You should feel that you are sitting in front of me and I'm teaching just like you are offline students. You are sitting in just front of me. Hey Ramu, hey Shamu, hey Sahana, hey Sausi. How many of you want to feel that you are sitting in front of me and I can understand each and every word? Sometimes silence speaks better than the words that lies in between a student and the best teacher. Today you will feel really connected with me, the best connectivity you are going to see today. I will take care of each and every single point that everyone should feel, yes, totally connected with me, and your problem, whatever is coming in your brain, that is going to be Baba HSP's problem today, kids. And those who are new, let me tell you, my dear students, this is your Baba HSP. I have been teaching for the last 26 plus years. In 1999, gold medalist. I've done my MTech in 2004, and after doing MSc, I did my GATE, JRF, and I have been teaching, produced number of ranks, you know very well, first, second, third, both in IIT, JEE as well as your NEET, my dear students. This topic, the alkane topic, is equally good for class 11th people, droppers, JEE, NEET, for everyone. Now, before I start, I would like to ask some likes, sharing, and you can help others. Sharing is caring, you can help others. God, Almighty God is going to help you a lot. But before I start hydrocarbon and alkane, my dear students, first of all, see a little bit, you can help others. Now see, your first step to assured excellent, flat 50% off on all NEET UG subscriptions. Get NEET UG assured on all iconic subscriptions. Offer ends tonight. Now, if you want to avail this fantastic offer, you have to use code HSP10. What? HSP10. HSP10. This is the code HSP10. Can you see, kids? You will get all the benefits along with Baba HSP's mentorship, the Avengers team. Right? Now let's see. Here is your Baba HSP. Your Yava sir, physics greatest teacher, and you know very well the Thalaiba, our Wasim sir, and Ambika ma'am, the best bio. And this is your Baba HSP, simple teacher, right? So Team Avengers, again and again I'm telling you, Team Avengers, Team Avengers, Team Avengers, NEET 2025 batch, Phoenix Masters, now just for rupees 4,999, September 30th onwards. Now, once again, I'm telling you, don't forget to use HSP10 is the code. Don't put Baba over there. Only HSP10. Now, before I start, before I tell you anything, kids, let me tell you, Nimbus. Nimbus means class 11th. You can call Nimbus batch as class 11th or Nurture batch, class 11th. Now 500 lectures, 20 plus test in English, rupees just 4,999. Now once again I'm telling you, use HSP10 as the code. The same thing is available. The best, India's best, world's best team, right? Okay, now see, kids. Sachin, Neha, Baba HSP, UNSAT, Unacademy National Scholarship and Aptitude Test. You know very well, register now, my dear students. So these were the informations which I want to tell you. My dear students, now let me see once the chat, and then I'm going to start. I want to see your names and I want to see your attendance to be marked. Then I'm going to start, because Alkane chapter is the first chapter. Now I'm going to see the screen. You have to mark your attendance by, yes, smashing the like button. Hit the like button. Just let me check it out. How many of you are present? South CHSPN is there. Nitish, Warren, Namita. I want to see the speed of the chat. How many students are there? Everyone. I want to see green hearts from your side, kids. This is your Baba HSP. Today, let me tell you, today Baba will not take a long session. Why? Because alkane, only alkane. So, it will get completed in its time. So, we happy? Don't worry. It's just alkane. Today, I am going to take just alkane. Not alkene, not alkyne. You will get proper time. My motive is to explain each and everything. Now, let me see. Kumboj, Madhu, Anamika, Sahana, Wow, Sahana, Margaret, Akshay, Priya, Rarafat, Kebya, Mary, Gorapin, Because, Solvi, Sahana, HSP, Madesh, Wow, Will. Yeah, wow, fantastic. It's fantastic. But why the likes are so less? Kids, you are not hitting the like buttons. And only one like button is there, but you have not done that, kids. Baba will cry. Baba will start crying. Monica, Priyadarshini, tell everyone to hit the like button. Oh, sorry, DPPs. Today I will share both the DPPs. Kids, I will share the DPP of isomerism also, and I will share the DPP of today's lecture also. Okay, both the two DPPs I will share today after completing the lecture. This is Baba's promise. This is Baba's promise. Kids, you have not smashed the like button. This is not. So today I will make this chapter easy peasy lemon squeezy. Easy peasy lemon squeezy. Everyone, being HSP army, HSP. Okay. Now let's it go. Let's it go, kids. Let's it go. Let's it go. Yeah. Now, let me tell you, kids. Before I start, let me tell you something. Alkane. You know, alkanes are saturated. Alkanes are saturated compounds. What are alkanes? Alkanes are saturated. So if I talk about alkane family, then I will say that least chemical reactions, if they are given, then they are given just for alkanes. The chapter alkane is in class 11th part 2 NCERT. Least chemical reactions are given in this alkane chapter. Least chemical reactions. Chemical reactions are least. Why? Because alkanes, if I write alkane, carbon, carbon, bro, bro, carbon, carbon, bro, bro, carbon, carbon, bro, bro, catenation property. So they are generally non-polar, non-polar, and they are being saturated. So they have least reactions. They show very, very less chemical properties. You know, molecular formula is CnH2n plus 2. They are saturated compounds, saturated. But this chapter holds a hell lot of weightage. It is really very, very important. So, I will start with the hydrogenation process. Hydrogenation. Baba will start with hydrogenation, kids. What? Hydrogenation. So, if I talk about the sequence of the NCERT, hydrogenation. Do you know hydrogenation? What do you mean by hydrogenation? That unsaturated compounds will become saturated. This is very easy, but I will start from the scratch and I will tell you each and everything. This is going to take at least 40 minutes. Are you ready for this? Just hydrogenation, which is given of 4 lines in your NCERT, but I am saying it will take 40 minutes. Are you ready, kids? Today I will really want to make a good connectivity with each and every one of you and sequence. I am going to follow. Ready? Ready. Now, hydrogenation. Simply if I say that how the hydrogenation will take place, if I simply write down CH2 double bond CH2 H2 nickel palladium platinum, nickel or palladium or platinum, they are being the catalyst, they will form ethane. Now, my dear student, the catalyst, word catalyst, how many of you say catalyst is involved in the reaction? If your answer is catalyst is involved in the reaction, catalyst. Option A, involved in reaction, involved in reaction. Option B, not involved in reaction, not involved. Now let me check what is your answer. If it is involved, I want to see green hearts from your side. If your answer is involved, then I want to see green hearts. If your answer is not involved, I want to see fire. Show me. If your answer is catalyst is involved in reaction, green heart. If your answer is catalyst is not involved in reaction, fire. I want to see. Kids, today I want to get a good connectivity with you people. Fast. Let me see and let go on. Let's move on. See, I can see the fire. Deepavali is there. Diwali fire. Some green hearts are also there. Along with some green hearts. See, the fire, maximum people are showing fire, but some people are showing green heart also. Now, let me tell you, my dear students, about the catalyst. See, you can check out that catalyst is very simple thing, but we are getting number of types of answers. Some are saying catalyst is not involved in the reaction, and some are saying catalyst are involved in the reaction. Just check out. Very simple thing. Now, if I talk about, my dear students, this is your house. And this is your school. SCHOOL, school. Now, if Champa is going to school by barefoot, then Champa is taking, suppose, 1 hour to reach to school. And if Champa is going with scooty, then Champa will take more time or less time. Definitely she is going to take 10 minutes only. Now, do you think this scooty, Champa, while going to school, will be bonded with the scooty or not? Yes. Champa will sit and the scooty will move, and Champa will sit on the scooty, and then the scooty, the whole way, scooty will be bonded with Champa, but scooty will not go inside the school and scooty will not go inside the house. But during the process, scooty was involved, and scooty is the catalyst. Remember, my dear students, the definition of catalyst. What is the definition of catalyst? So, always remember that catalyst is a substance, chemical or biological, biochemical, enzymes like, which takes part in the reaction, during the reaction, but just before the completion of the reaction, comes back in its original form. So everyone thinks like that. Catalyst has not done anything. Catalyst was not involved in the reaction. If you have seen the enzymes throughout the process, they are involved, like Michael-Mentius equation in zoology you must have studied. They are making activated complex. They are decreasing the activation energy. So catalysts are always involved in the reaction. So who is correct? Who is winner? Those who have shown me the green hearts, they were correct. They were very few, but still they were correct. Remember that catalyst during the reaction, they takes part, but catalyst can never start the reaction. Catalyst can never start the reaction. The reaction which is not going to take place, catalyst cannot start the reaction. Catalyst can't start the reaction, can never start the reaction, Clear? Agreed? If you are agreed, I want to see green heart. Kids, today my main motive is to give that feeling that you are my kids and you are in front of me. Then it's your duty, then you have to show the signal. If you are agreed, I want to see green hearts, kids. Baba want to see green hearts, kids. If you are really agreed, if you got it, everyone, if you got it, kids. Thank you, kids. Thank you. Wow, fantastic. Now, let me show you how the catalysts, they are taking part. Let's see how the catalysts, they are going to form a bond. Let me show you, kids. See, if I say, this is a nickel plate, nickel, many nickels are over here, many nickels are present over here, nickel. Now, do you know nickel, kids? If I show you nickel, then the atomic number of nickel, do you know atomic number of nickel? Science teacher, very crazy man. Felt cold in night with cousin, 28. Nickel's atomic number is 28. Now, if I talk about nickel's electronic configuration, then definitely the configuration will come 3d, 8 and 4s2. Now, it is having vacant d orbitals. Vacant d orbitals means they are very good catalysts. So, if I say it is a catalyst, kids, it's a catalyst, nickel is there, nickel is there, nickel is there, nickel is there, nickel is there. They are having holes, and you know that without the presence of this catalyst, if I say the hydrogen gas, the hydrogen is a gas. If hydrogen molecules, they were flying somewhere, they were singing, hey, somebody must be waiting, watching us. We wanna form a bond. So they are flying. Hydrogen gas is flying. Somewhere ethylene gas is also flying. Just you know that in the movie there is one actress, there is one hero. Hero doesn't know about heroine and heroine doesn't know about hero. If they know each other also, that they are scared. How to say, what to say. Oh my God, they are not able to say, they are not able to express. Then one day there is the entry of villain. Da-da-da, then the fight with the hero. Then hero will start bleeding and the heroine will come and will say some few words and then the process will start. Now just like that, this is the surface. They are going to provide surface. If you see your NCERT, then I will say surface. Now my dear students, in your home, if there is surface, you just see any surface and you put your hand like this, you rub a little bit your hand on that. Bring your, some slab is there, put your hands like this and just see your hand. See, the hand will become dirty. That this process of adsorption takes place by its own. No one is going to do this process. This process is a spontaneous process, the adsorption, that on the metal solid surface gases will get absorbed automatically. So this hydrogen will come and it will get absorbed over here. This hydrogen gas is going to come and it will get adsorbed. It is going to adsorb at this place. If it is getting adsorbed, it is locked. So hydrogen gas will get locked. So hydrogen and hydrogen. Now after some day or after few moments, this ethylene gas will also come. It's like a hotel. You can say it's like a hotel that already hydrogen is there and it got adsorbed, and that alkene is going to come. Hey, I'm coming, I'm ethylene, I am ethylene, I have got pi bond. Hey, hydrogen, who are you? I'm the gas, but I'm staying on this nickel. I got adsorbed. You also come and let's form a bond. So see, they will start forming a bond. This bond will be broken, and this bond is also going to break. Now they will start forming a bond. See this bond, and see both the two hydrogens are getting added from the same side. Same side addition is also known as syn addition. Remember that this is known as what? Syn addition. Remember that this is syn addition. Number of questions will be asked from syn. And just see, this is a 4-membered transition state. Can you see 4-membered transition state? Everyone, can you see 4-membered cyclic transition state? Highly unstable, but yes, it has provided a site, and we will say this is adsorption has taken place. Adsorption. Till now, is it clear, kids? Till now, is it clear? If yes, I want to see green signal. Till now, is it clear? Till now, is it clear? The diagram is clear, each and everything. I want to see your messages, because today I have promised you to form a good connect with you, kids. Kids, do let me know. At least I am trying this much hard, kids. I want to see that my kids are able to understand or not, my dear students. Baba is trying his level best. So definitely, kids, you are getting it. Syn addition, 4-membered cyclic transition state. Okay. Kiran Pathak ji. Yeah, definitely I will explain each and everything. Kids. Okay, please once more. Maximum students are asking, please once more. Let me tell you once again. Just wait and watch. See. If I say, kids, that this is the nickel surface. This is the metal surface, either nickel, palladium or platinum. Anything can be there. These are the holes. There are the holes. This is the nickel or palladium or platinum. I can take nickel, palladium or platinum. They are very good catalyst, kids. So there are holes. Now the hydrogen gas is coming, and hydrogen gas was moving through it. The hydrogen gas was moving through it, was passing through it like this. Gas was moving, but gas got entrapped over here. This hydrogen gas got entrapped. It was moving, the hydrogen gas got entrapped over here in the holes. It has got adsorbed. This is known as adsorption. Adsorption. What is the adsorption, kids? Adsorption is a surface phenomena. What is surface phenomena? That if you see the solid surface, the gases, they are getting adsorbed on the surface. From another side, the ethylene gas was moving, and this gas was moving like this, and this gas has also got adsorbed. Both the gases got adsorbed on these holes. They got trapped. This is just, you can say, the predator, and they got trapped on this surface. Are you getting my point? The hydrogen gas got trapped over here. The alkene gas got trapped over here. Now these have come closer. They have come closer. Now how they will form the bond? Just see how they will form the bond, because they got trapped. Once they got trapped, my dear students, they will form a bond. Like, see how? If I say this was the hole, and the hydrogen gas, one hydrogen molecule, the hydrogen gas is like this. They got trapped over here. Now hydrogen gas is waiting. Just, you can say, these hydrogens will be a little bit, you can say, you can draw it over here also, because number of holes are there. Don't think they are on that side. This is the 3D diagram. They are on the surface. Just, you see, this is the surface, I can draw hydrogen gas molecules are like this. They are adsorbed over here. This is one hydrogen. Now the ethylene molecule or any alkene will come like this. The alkene is having the pi bond. If they are having pi bond, this pi bond, if I talk about this is the pi bond, then their lobes will be there. The lobes of the pi bond will be like this, and the lobes of this pi bond, they will form interacting with this hydrogen. So both the hydrogens will come from the same side. They will get added from the same side. Let me tell you how they will get added from the same side. It should be like this. The bond should be like this. This hydrogen and this hydrogen, both the two gases, now they will start forming a bond like this. The pi bond will break, and the pi bond will break, and so the hydrogen gas molecules, they will start breaking from here, and they will forming a bond at this place. Just see, kids, they will start forming a bond over here. Now see how many membered transition state. This is the 4-membered, 1 atom, 2 atom, 3 atom, 4 atom. This 4-membered transition state, I have told you, this is your 4-membered transition state. That 4 atoms are involved. Can you see, kids? These are the 4 atoms which are involved. 4-membered cyclic transition state. Now, my dear student, there is no mechanism. This is 4-membered cyclic transition state, and this is known as concerted mechanism. What do you mean by concerted mechanism? The meaning of concerted mechanism is that single step process. This is going to be single step. My dear students, now you got it. Those who said that, once again, Baba, once again, kids, you got it. If yes, kids, if really you got it. Those who asked, once again, Baba, Baba has explained once again, kids, do let me know you have got it or not. Where are you, kids? You got it or not? Where are you, kids? Thank you, Nitish, Varan, thank you, really thanks. Now, Monica, thank you, really thanks. Oh, lag is there. Just wait, kids. Can you hear me? Can you see the screen, kids, or it's lagging? Can you see the screen or it's lagging? Kids, everything is okay? Is everything okay, kids? Okay, thank you, kids. Thank you, kids. Thank you. Now, let me tell you, with this, we can say that if I say that we got this hydrogen, this nickel surface, we have got this nickel surface, and we have got this hydrogen at this place, and we got any alkene at this place, Now, kids, if I make these groups R1, R2, R3, R4. If I increase the bulkiness, then what is going to happen, kids? If I increase the bulkiness, this much bulky group, if I say the groups, if I add bulky groups, these many groups, all three bulky groups, do you think that hydrogenation is going to be easy? If I increase the bulkiness, then these hydrogen will feel difficulty in forming transition state or not? Yes, they will feel difficulty. So I will say that rate of hydrogenation is inversely proportional to what? To steric hindrance. One point is very much clear to all of you. And because the pi bond is breaking, kids, because the pi bond is breaking and two new sigma bonds are getting formed through this cyclic 4-membered transition state. So one pi bond is breaking and two new sigma bonds are getting formed. So this is exothermic reaction. This point is clear. Exothermic. Why it is being exothermic process, exothermic reaction? Because one pi bond is breaking. Just see, if I say that how many pi bonds are breaking in between these molecules, this one pi bond will break and two new sigma bonds are getting formed. Just see, one pi bond is breaking and two new sigma bonds are getting formed. Remember that energy is required to break the bond. Energy is required. Just as a big bond, energy is required. Two new sigma bonds are getting formed. More energy is released. So what will you say, kids? You must have studied delta H. Delta H of reaction is equal to final minus initial reaction. Product minus reactant. Product is less and this is more. So less minus more will come out negative, exothermic, and this is known as what? This is known as heat of hydrogenation. This is known as what, kids? Heat of hydrogenation. So how will you define heat of hydrogenation? Heat of hydrogenation. Kids, are you getting my point? Till now it's clear. It is exothermic reaction. Why it is exothermic, kids? Is it clear? Is it clear, kids? Is it clear? Now see, let me define. If I ask one question, just answer that question. If I ask one question, that heat of hydrogenation, heat of hydrogenation is directly proportional to or inversely proportional to stability of alkene, right or wrong? Stability of alkene. Once again, if you say it's correct, then I want to see green heart. If your answer is correct, green heart. And if your answer is wrong, if this expression is wrong, then I want to see fire in the chat section. So heat of hydrogenation is inversely proportional to stability of alkene. If you say it is correct, whatever the data is written, if you are agreed with that, then show me green heart. If you say it is wrongly written, then I want to see fire in the chat section. Kids, do let me know. Let me check it out how much you are getting. Let me see what you are writing in the chat section. So you can check this symbol will show you that how many of you are agreed and rest of how many of you are not agreed. Just see, maximum people are showing the green heart. Just see, correct. For if you say this is correct, show me green heart. If you say this is wrong, show me fire. Everyone, only 1 or 2 students are showing me fire, rest of others are showing green heart. This is wrong. This is totally wrong, kids. This is totally wrong. Examiner will give you big zero, big zero. Just see your answers. Just check it out, your answers. You will get 0 marks. It's totally wrong, kids. Totally wrong. It's wrong, wrong, wrong. Now you will say, sir, we have studied like this. What are you saying? Let me tell you, kids. Let me tell you. Just wait and watch. If I say that this compound is having 3 pi bonds, 3 pi bonds, 3 pi bonds, 3 pi bonds, and there is resonance also. It is stabilized by resonance. This compound is stabilized by resonance. And if I say there, I'm having just one compound, CH3, CH double bond, CH, CH3. There is no resonance, no resonance, no resonance. Gets which molecule is more stable? That. But remember that this is A and that is your B. Here 1 pi bond, 2 pi bonds and 3 pi bonds. When 3 pi bonds are going to break, how many new sigma bonds will get formed? 6 new sigma bonds will get formed. That in place of 3 pi bonds, 6 new sigma bonds. Whenever the sigma bond is getting formed, energy will get released. Here only 1 pi bond is going to break. In place of 1 pi bond, you will get 2 new sigma bond. Who will release more energy? Definitely the answer is this. This will release more energy. Definitely, you are agreed or not, will release more energy, maximum energy. Agreed or not? Agreed. If agreed, show me green hearts. This will release less energy. So its heat of hydrogenation will be very, very high. So first we have to see the number of pi bonds. Never see the stability first. If agreed, I want to see green hearts, kids. If you are agreed what I am saying. So the formula will come out to be heat of hydrogenation is directly proportional to number of pi bonds. Number of pi bonds. Now what do you say? This is right or wrong? Now what will you say? This is right or wrong? Is this right or wrong? If this is right according to you, show me fire. If you say this is right, show me green hearts. If your answer is that this is right, I want to see green hearts. Those who say, kids, this is even not correct. This is not correct. Everyone is saying this is right. Okay? If you say this is right, how many of you are saying this is right, kids? How many of you are saying this is right? This is right. Okay, let's see. CH3, C double bond O, C triple bond N. It is having 1, 2, 3 pi bond, and CH2 double bond CH, CH2, CH double bond CH2. This is having 3 pi bonds. This is having 2 pi bonds, which will have more heat of hydrogenation. Out of A and B, which will have more heat of hydrogenation? Just to let me know, which will have more heat of hydrogenation? What's your answer, A or B? Tell me. Let's see how much intelligent you are. Let's see how much intelligent you are. Which one is correct, kids? Show me the green hearts. Show me, kids. Yeah, now your answer is correct. That you are saying B is having B. You are going for B. Now, kids, Once you are going for B, this is the correct answer, then will you say this is correct? You said that heat of hydrogenation is directly proportional to number of pi bond. This is having 3 pi bond, this is having just 2. Then why you have gone for the second one, less number of pi bond, when you are saying this is correct? Kids, remember that if we say heat of hydrogenation is directly proportional to number of pi bonds in between carbon and carbon, because carbon and carbon, if they are going to form, we will say unsaturated. This compound is not unsaturated. It is not. This compound is not unsaturated. When we want to see saturation or unsaturation, we have to see carbon to carbon pi bond. This is unsaturated. This compound is unsaturated. Now you got it. Now you are able to understand that condition should be given, then it is correct, otherwise it is not going to be correct. Agreed? Today Baba wants to form a bond with you, kids. So in each and every point, at every moment, I would like to see that you are able to understand or not, kids. You are getting it or not, kids. Baba want to see that everyone is able to understand or not. Kids, fast. Thank you kids, thank you. Now, so ultimately what is going to come over here, just see that heat of hydrogenation is directly proportional to number of pi bonds in between carbon and carbon. And if number of pi bonds are same, first always see this point. If number of pi bonds are same, we will say that heat of hydrogenation is inversely proportional to stability of alkene, but this is valid only when pi bonds number is same, kids, number is same. I hope that you got it. Let me give you one example of this. Let me teach you one example of this, then you can understand. But first of all, do let me know this point is clear. I hope this point is clear to each and everyone. Now Baba is going to give you example of this. All the two things Baba will explain, both the two things. Just see, Baba is going to explain both the two things. I hope that everyone is ready. Now see, kids, the first thing, let me complete that one, that CH2 unsubstituted alkene, this is least sterically hindered, no substitution is there. This will have maximum heat of hydrogenation. After that, if I put 1 methyl in place of hydrogen, monosubstituted alkene will have heat of hydrogenation. Then after this, I would like to say in the disubstituted, after this the number will come to the cis alkene. Why the cis alkene is over here? Just see, disubstituted and disubstituted. I will show you 3 examples. Cis, then trans, and then the gem 1. Now see, kids, why it's like this. This is the most dangerous one. All these 3 are disubstituted. But see, if the hydrogen is coming over here, hydrogen can easily form bond from here to here, because these 2 hydrogens are very small. I hope that you're getting it. But here, this hydrogen can easily form bond, but this hydrogen will feel difficulty. So this hydrogen can easily form the bond, but that is feeling a steric hindrance. But see over here, this hydrogen can ultimately form a bond, but this hydrogen will feel steric hindrance, too much steric hindrance. So in disubstituted, it is going to be like this. Now if I talk about trisubstituted, will have even lesser than that. This is tri-substituted kids, and the tetra-substituted will have least heat of hydrogenation, least heat of hydrogenation. I hope that everyone is getting. So on number 1, we will have heat of hydrogenation of this ethene, unsubstituted, then monosubstituted, then these all are what? Di-substituted. Third number, fourth number, this will be on fifth number, and this will be on sixth number, and this will be on seventh number. I hope that everyone is able to understand. Kids, everyone is able to understand. This will be the order for heat of hydrogenation. Now, the question arises, kids, that arrange the following in decreasing order of heat of hydrogenation. Will you try, kids? Will you try? Just see the compounds. First compound is CH2 double bond CH, CH double bond CH, CH double bond CH2. This is the first compound. Second compound is CH2 double bond CH, CH double bond CH, CH3. Now the third compound is CH2 double bond CH, CH2, CH double bond CH2. The third compound, after third compound, fourth compound is CH2 double bond CH, CH2, CH2, CH3, and the last compound, fifth compound is CH3, CH double bond CH, CH2, CH3. Now, which will have maximum heat of hydrogenation? Let me check it out in the chat section. I'm there. Let me come over here in front of the screen and let me see what's the answer, kids. Maximum, just to let me know who is having maximum heat of hydrogenation. Let me check it out. Which one is having maximum? It's confusing. Okay. Kids, some of you are saying that not able to understand. Some are saying Baba is going slow. Kids, if Baba is moving fast, then how you will be able to understand, kids? What is this? Kids, what's that? Just see, kids, just see. Let me tell you, kids. First, if you want to understand, kids, see 1 pi bond, 1 pi bond, 1 pi bond. It is having 3 pi bonds. Just count the number of pi bonds. 3. It is having 1, 2, 1, 2. 2 pi bonds. Just classify and separate 2 pi bonds. Now see, only 1 pi bond, only 1 pi bond. Thus separate it out, kids. 1 pi bond. Separate it. Now what I said, the one with maximum number of pi bond will have maximum heat of hydrogenation. So definitely the first one is going to have maximum heat of hydrogenation. Clear? Clear? Is it clear? Now see, these two are having 1 pi bond. It is having 2 alpha hydrogen atoms. The fourth one is having 2 alpha hydrogen atoms, and this is having just see 3 and 2. 3 alpha hydrogen atoms, 2 alpha hydrogen atoms, so total 5 alpha hydrogen atoms. When the number of pi bonds are same, the one who is more stable one will have less heat of hydrogenation. More stable, less heat of hydrogenation. So this will have more and this will have least. So starting with 1 and it will end on 5th one. This is clear. 1 will have maximum heat of hydrogenation and 5th will have least heat of hydrogenation. If this point is clear, then we will go for rest of the other things. We will say that 4th will have more than that. And now decide in between these two. Double bond, single bond, double bond. It is stabilized by resonance. There is a resonance. Here is no resonance. So out of these, who is more stable? This is more stable. So we'll have less. So 3. After 1, it will be 3. And after that, it will be 2. Now who is left? 1, 3, 2, 4, 5. This is going to be the answer. And this question was really fantastic question. If you got it, do let me know. Do let me know kids got it or not. This was a really tough question. If you got it, I want to see that you are able to understand. If not, Baba will tell you again. Sir, it is Garapati, it is alkane, because we will do the hydrogenation of alkane and we will do the hydrogenation of alkene and we will get alkane. So right now we are dealing with alkane. Now how to decide, kids? Those who don't know where is resonance, where is no resonance. See, if kids, just see if alternate pi and sigma, pi, sigma, pi, pi, sigma, pi, this is resonance. Now in between 2 pi bonds, if there are more than 1 sigma bond, no resonance. Let me tell you on another screen. If you see compound like this, kids, if you see compound like this, pi, sigma, pi, alternate pi bonds, alternate pi bonds, alternate pi bond, then there is resonance. There is resonance, kids. There is resonance. If the pi bonds are present like this, C double bond C, 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 and then double bond C, or simply one pi bond is there like this, and there is no another pi bond, then we will say what, kids? We will say there is no resonance. Just see pi, now sigma, 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 and then pi. So pi bonds are separated. They are alone. There is no conjugation. There is only one pi bond. So they are not having resonance. No resonance. Kids, those who are not able to understand resonance, are you able to get it? No resonance. And alternate pi bonds, there is resonance, kids. Now you got it, kids. Now if there is resonance, the compound will be more stable. This is less stable. These two are less stable. That is more stable. More stable, less stable. You got it? Now some of you are asking, sir, this is alkene or alkane? See, from where I have started, kids. From where I have started, just tell me what I was teaching you. From where I have started, kids, that I have started from the hydrogenation. Once I am going to do the hydrogenation of alkene, then I am going to get alkane. This was the process. From here I have started, that if you are doing the hydrogenation of alkene or alkynes, you will get alkane. So automatically the reactant is being unsaturated compound, that can be either alkene or alkyne, and then only you are going to get alkane. Now which compound is going to give speedily the alkane? That question will be based. So if you are studying alkane, then alkene is there, kids. You are getting it. Some of you are thinking that, sir, the chapter's name is alkane and every time it is going alkene. From alkene only we are going to prepare alkane. Kids, is it idiyappam murku or romba sulbam nalla irku? Kids, are you getting it or not? Just to let me know. Kids, Baba is giving you the quality content. Baba is telling you again and again, kids. Now, kids, your understanding matters a lot. Alpha hydrogen is more stable, that is hyperconjugation. Kids, that is hyperconjugation, not the resonance. Alpha hydrogen more than that is not resonance, that is hyperconjugation. Kids, your understanding matters a lot to me, kids. Nalla Iriku, Romba Sulbham, Arpudham Madhumita, very good, kids. Very good. Now see, kids. Now see. Now some of you want to complete it. Kids, let me tell you, I am not a kind of teacher that who is going to complete one chapter speedily. If you want to get rank, if you want to get selection, then you have to give time. You must be thinking, sir, you are not able to complete only hydrogenation. Just should I complete by telling you few reactions? Nothing to worry about your selection. Should I not? I'm not having any right to think about your selection, about your rank. Or simply I am on this YouTube channel to tell you very fastly, speedily, just to complete one chapter, so that am I here for the views? Am I here for the likes? Or am here to tell you each and everything in detail, kids? Now, kids, some of you are really kiddo kids, so for those students, let me tell you, that is stability. Some are thinking about a stability, kids. Stability of alkene depends on two things. Is directly proportional to resonance, if resonance is there, and stability of alkene, if no resonance is there, then stability of alkene is directly proportional to number of alpha hydrogen. These two things are different, kids. That is the resonance, and here is the hyperconjugation. If your basic concepts are not clear, kids, then do let me know. I will make it clear, but don't say that increase the speed. Kids, I'm not like general YouTubers who is going to just complete each and everything for the views, who will move according to you, kids. I'm a teacher. I teach for your rank. If even I'm teaching for free of cost, then also I'm teaching for the rank, not for the views. Am I right or wrong? Just do let me know. Am I right or wrong? I want to see. Let me see what you're writing, kids. Am I right or wrong? What I'm thinking? Yes, Rakesh, unsaturated is decided by C and C only, or C triple bond C. C triple bond C or C double bond C. I want to see your explanation. I want to see what you want, kids. Just completing any topic within fraction of seconds, or I should wait for your rank, kids. Do let me know what is more important. Now see, kids. Now see. So remember that one point. Remember that one point, that if any alkene or any alkyne, we are reacting with hydrogen. We are reacting with hydrogen. We are reacting. This is alkene. This is alkyne. It will require one molecule of hydrogen, H2. It will get converted into alkane. saturated compound. It will get converted into saturated. It will require 2 molecules of hydrogen. That means more hydrogen. Then it will also get converted into alkane kits. Both are getting converted into alkane. The catalyst, we can use nickel or palladium or platinum, whatever you want to use. But remember that if you are using nickel at catalyst, once the nickel is used as the catalyst, suppose if I write down any reaction, and if you are using nickel as the catalyst, then what should be the name of this reaction? This reaction will be known as kits. This reaction will be known as, reaction will be called as what? Reaction will be known as Sabatier and Sanderson's method. Sabatier, remember that, Sabatier's and Sanderson's method. Sanderson's method. Is it clear? If you use any other catalyst, no problem. But if you are using nickel as the catalyst, then the reaction will be known as what? Sabatier and Sanderson's method. Sabatier and Sanderson's. Now, in place of nickel, you can also use Rane nickel. Rane nickel. Now, what is the difference between nickel and Rane nickel? My dear students, when you are using just nickel, you have to use at least 100 degrees Celsius temperature. 100 degrees Celsius temperature. You know that one thing very well, that if I say vegetable oil, vegetable oils, they are what? They are being unsaturated triesters of fatty acids, unsaturated. Now, if you are using hydrogen in presence of nickel and 100 degrees Celsius temperature, they will convert into vanaspati ghee. Now you will say where it is written in alkane kits. If you want to get rank, then everything is not written in NCERT. You have to follow these notes, $1 million notes. Now see, if you are providing this much of temperature, this will break down the vegetable oil. Vegetable oil will break down, and once the vegetable oil is going to break down, kids, it will become carcinogenic, and that's why people say that don't use samosa, don't eat samosa pakodis like that. They are carcinogenic. Now scientists, they have developed one approach that how to convert vegetable oil into vanaspati ghee without using this temperature, Then they got one technique that oil can get converted into vanaspati ghee without using temperature. Then how? They used Rane nickel, Rane nickel. Now no temperature is required. This will take place at room temperature. The hydrogenation. This is the hydrogenation process, kids. This is only the hydrogenation process at room temperature. Now what is Rane nickel? They will ask what is Rane nickel. Rane nickel is an alloy, of nickel plus aluminium powder in presence of NaOH. So they can directly ask this question, what is Rane nickel? Remember that Rane nickel is an alloy of nickel, aluminium and NaOH. Is it clear, kids? Now how the speed will increase? If I am giving you this much of content, do you think that I can increase this much of the speed, kids? You are getting it? I want to see your comments, kids. You are able to understand or not? Tell me, kids. Tell me. even in place of Rani nickel, you can use another thing, kids. You know, if you know, kids, those who are intelligent, definitely they must be having that an alkene, if you want to convert into alkane, there is one thing, Wilkinson's catalyst. Have you heard this name, Wilkinson's catalyst? Have you ever heard this name? Then also you will get alkane. Now they will ask you, what is Wilkinson's catalyst? What is this? So remember that it is triphenylphosphine rhodium chloride, RHCl, triphenylphosphine, PPH3, PPH3. What is the name, kids? Triphenylphosphine. They can even write down the name, triphenylphosphine rhodium chloride. I hope this is clear, kids. Is it clear? This is complex compound. This can even change into alkane. So my dear students, now let me come back and let me tell you some more points which holds a hell lot of weightage. But till now, if it is clear, then only Baba is going to tell you. I want to see green hearts, kids. You are able to understand or not? Now let me tell you, kids. If I am having, suppose if I am having CH3, C triple bond C, CH3, this is butene. Now butene, if I react it with Lindlar's catalyst, what is Lindlar's catalyst, kids? Lindlar's catalyst. Tell me. H2PDC. If anyone is writing H2PDC like NCERT, it's okay. But if NCERT is writing H2PDC, barium sulfate, charcoal, boiling xylene, quinoline, then also it is Lindlar's catalyst only. If this much is given, the property of this is it will form cis alkene. What is the property? It will form cis alkene. Cis alkene will be the product. Now my dear friends, if I add hydrogen to this, but in place of hydrogen, if he is using D2, now what should be the answer? If he is using D2, if he has used hydrogen, no problem is there, because the carbon will not become chiral. See, if he is using H2 nickel, then there is no problem, because you will get CH3, CH2, CH2, CH3. But if he is using D2 nickel, then there is problem, because the compound can either be trio or erythrio, or I can say it is meso or racemic mixture. Now you will say, sir, we don't know what is racemic mixture, what is trio and erythrio. The earlier lecture, before this, the lecture I took for isomerism. So should I tell you this or not? Do let me know whether you are going to get trio, erythrio, racemic, meso, what you are going to get, the product. Should I tell you or not? Do let me know. Do let me know in the chat section, kids. I want to see. Okay, I will come to that Wurtz reduction also, kids. But before that, do let me know you are able to understand this one or not, kids. Do let me know, kids. Okay, just see, kids. I will come back to this, but listen to me. Listen to me. If I tell you kids that I am having compound like this, remember that if I am having compound like this, and I am having compound like this, carbon, carbon, H, CH3, CH3, this is your cis alkene, cis, and if I say hydrogen, hydrogen, CH3, CH3, we know that this is trans, trans. Remember that if I add D2, if I add D2, how it will add up? It will come over here, it will come over here, it will get attached to this, right? It will get attached to this. Now the bond formed will be, just remember my trick, Baba HSP's trick, Baba HSP's trick. CSM, remember that CSM, 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 C is M. Now what you will get? CH3, CH3 and D2 will add up. So I can make this compound like this also, see to it. Meso, CSM, that means you will get meso, D, CH3, H. So I can call it either meso or C, both the two D are on the same side, erythrio, meso, or I can call it erythrio. Now see kids, see everyone, or you can place anything. No need to say that here will be methyl. Here can be anything kids. These bonds can be anything. You can place here R1, R2 or R1, R3. Anything you can place here. If I say here is R1, here is R2, doesn't matter. R1, R2, doesn't matter kids. So here I will get R1, R2, doesn't matter my dear students. But if they are same, then plane of symmetry is there. If plane of symmetry is there, then it will be known as meso, R1, R2. Meso is only valid when there is plane of symmetry, then only meso. Now here what I will get kids, where in this, just remember that T, S, R, Tushar, that was CSM, this is Tushar. Now see what I will get over here kids, I will get compound like this. I will get compound like this. R means racemic means R1 over here, R2 at this place, and D2 will add up over here. Just see this is D and this is D. They will come from the same side. Sin means same side. Sin means same side. They will come from same side. Now this will be this side and that side. See, hydrogen over here, R1, R2 and one deuterium, or you can place deuterium. See, deuterium will come from this side. They will come from this side. Now one R will go this side, one R will go that side. Racemic I will get racemic, and there is hydrogen plus its mirror image. This you can say either racemic you can say, or you can talk about that one R1 is on this side, another R1 on that side. This is trio. You are able to understand or not? It's a little bit tougher, but you see, if you remember that CSM, M means on same side, TSR, racemic, then they are on opposite side. I don't think that everyone is able to understand. Do let me know kids in the chat section, you got it or not. Yes, Tam, Tusharkar, CSM. Let's see how many of you got it, kids. Kids, do let me know you got it or not. I cannot see that kids. Sahana is able to understand. Rest of the other students are not getting an idea about kids. Yes, kids, your chat means a lot to me, kids. What S stands for? Okay, that's fine question. Let me tell you what do you mean by S. See, C means cis. C means cis. Syn, because this is syn addition. Meso. T means trans. Syn. Racemic. I hope that it's clear to all of you. If this much is clear, then I can give you one table which is going to help you a lot, because I have started from here CH3, C triple bond C, CH3. Now see, kids, I have reacted it with Lindelar's catalyst. That is H2PDC. I got cis alkene. Now if I would have reacted with sodium liquid ammonia, then I would have got transalkene. This is known as Birch reduction. And even you can carry out this reaction with nickel boride P2 catalyst. Nickel boride Ni2B. Nickel boride also known as P2 catalyst. Nickel boride. You would have got the same, because this here, kids, a little bit tough paper will come. Remember that. Little bit tough paper will come, kids. So we have to nickel boride P2 catalyst, transalkene. Now see, kids, if I do reaction with what? If I do reaction with D2, remember that D2 is like deuterium, the isotope of hydrogen, and I have told you the mechanism is syn addition. From the starting I am telling you this will always do syn addition. This is cis. So just complete it, kids. Complete it. What I will write? C, the first letter C, the second letter S, CSM. Meso will be the product. If you're getting it, do let me know that. Here one CH3, here one D, here one D, here one CH3, here is hydrogen, here is hydrogen. Two chiral carbons are present, but then also it is becoming optically inactive due to presence of what? Due to the presence of what, kids? Due to the presence of one plane of symmetry is here. We can divide this molecule in two equal parts. Can you see, kids? This is the plane of symmetry. Now try to complete this one. T, trans, and this will also show syn addition. D2, that is being the syn addition. So what I will say, TS, complete it. TSR. What I will write, kids? TSR means I'm supposed to write down racemic mixture. I will draw like this. I will draw like this, I will draw it like this, I will go for this in this way, kids. Just see to it. I will go like this, that 1D over here, 1D over here, 1 CH3 over here, 1 H over here, 1 H over here, 1 CH3, and it's a mirror image of another one, D H CH3 CH3. So this is 50% dextro, 50% levo, racemic mixture. Kids, just see to it. You got it or not? If yes, show me green hearts in the chat section so that I can understand that you kids are really getting it or not, kids. Oh my God. Cis and syn. Cis and syn, almost they are same, kids. But this is the way of writing, because for cis is the compound, syn is the type of addition. Syn is the type of addition, kids. Cis and syn. Just do let me know, kids. Everyone do let me know, kids, you are getting it or not. Very good. Now let me come back. This was the hydrogenation, but the hydrogenation is not completed. See, hydrogen is not still completed. Why, kids? See to it. If they are giving you compound like this, CH2 double bond CH, CH double bond CH2, and they are giving you H2 just one equivalent, then what you are supposed to do? What you are supposed to do, kids? There are 2 pi bonds. So what do you think? What you will make? What will be the product? Just try it out. Just try it out. What should be the product? Now, my dear students, just remember that how to find out the solution of this question. Answer to this question, how to find it out. Just see, I will make CH2, CH, 1 free radical, 1 free radical, CH free radical, CH2 free radical. Now see, one hydrogen will add up over here. One hydrogen will add up over here and another hydrogen will add up over here. Just see to it, kids. Just see, this will form bond over here, this will form bond over here, and they will combine together. This is known as 1,4 addition. 1, 2, 3, 4. This is known as 1,4 addition product. 1,4 addition product, kids. Now why this is happening, kids? Let me show you. Let me tell you that CH2, CH2, they have formed the bond like this, double bond at this place. They formed hydrogen and they formed hydrogen. Now see this compound, how many alpha hydrogens are there in this compound? Adjacent to this, you can write it like this, CH3, CH double bond CH3. Now you can see 3 alpha hydrogens at this place and 3 hydrogens at that place. 6 alpha hydrogen atoms. So more the number of alpha hydrogen atoms, more is the stability of alkene. So maximum hyperconjugation. Maximum hyperconjugation. Why? Now my dear students, why it has done like this? See, if we have directly added 2 hydrogens at either here or there, we would have got what? We would have got compound like this, CH2 double bond CH, CH2, CH3. Now how many alpha hydrogens? Only 2 alpha hydrogen atoms. So that's why this compound is unstable. So this will not get formed. That compound will get formed. This is known as 1,4 addition. I hope that you got it. If you really got it, then let's do one question. Already they have asked this question, kids. Just see, if they have given you compound like this, just see to it. Now what you will do, kids? They have given hydrogen one equivalent only, one equivalent only. Now see kids, 1, 2, 3, 4, where you are going to add hydrogens. Now one hydrogen at this place, one hydrogen at this place. If you add over here, let me make transition state, otherwise you won't be able to understand. Let me make transition state. This is over here, this is over here. Now see kids, this free radical, this free radical, this free radical, this free radical. If I add one hydrogen at this place, form the bond, one hydrogen at this place, form the bond, and this will form a bond over here. Now see what product you have got. You have got product like this, you have got product like this, and this is more stable alkene. 1,4 addition, 1,4 addition is going to give you, see, 3 hydrogen, 3 alpha hydrogen, 2 alpha hydrogens at this place. Just see, 2 alpha hydrogens at this place and 2 alpha hydrogens at this place. 3 3 3 plus 3 plus 2 plus 2, 6 plus 4, 10 alpha hydrogen atoms. So highly stable product, highly stable product you got. I hope you got it. If you got it, really got it, this is example of 1,4 addition. If you really got it, kids, do let me know in the chat section with the green hearts. Then, oh my god, already have shown the green hearts, kids. Now you are able to understand or not? Do let me know. Now you are able to understand or not, kids? I want to see that you people are able to understand or not, kids. Everyone, just to let me know. Hey everyone. Getting it. Everyone is able to understand. That's really awesome. That's really awesome. Really awesome. Very level, Rakesh. Thank you. Now you got it. Super. Now kids, you are getting it really. Fantastic, kids. Fantastic. Now the hydrogenation is completed. Now I would like to say, yes, hydrogenation is completed. Now, kids, once the hydrogenation is completed, I cannot move ahead without asking you one question. Now is the time to ask one question, then only it will get completed. Otherwise, how? It will not get completed. See, question is, find out all possible types of alkenes, including stereoisomers, alkenes or alkene undergoing hydrogenation to give you compound like this. They have formed a compound like this. Now what's your answer? How many types of alkenes will form this compound? The question is, how many types of alkenes including stereoisomers are possible which will form this compound? 1-methyl cyclobutane. Tell me your answer in the chat section. How many possibilities are there? Let me see your answer, kids. Kids, do let me know. One kid is writing 3 types. Kids, do let me know. 3 types. Everyone, most of the kids are writing 3 types. Let me check it out. Maximum kids are writing 3 types. Let me check, kids. Let me check on the next page. This is your target. This is your target. So what I can do, I can make this compound and I can put double bond at this place. This is 1 because can't show GI. Can't show GI, so it is going to be counted as 1 only, right? Dead. Can't show GI. Can't show GI. GI means geometrical isomerism. So I will count it to be 1 only. Let me draw another one. If I draw it like this, and if I put here double bond, once again it is double bond inside, valency 1, 2, 3, 4, can't show GI. GI it cannot show, can't show GI. I will count it as 1, only 1. Now if I say, if I draw a compound like this, if I draw a compound like this, my dear student, just see, this carbon has become chiral or not? This carbon has become chiral. See kids, this carbon is chiral. This carbon is chiral. Now chiral means it will be counted as 2. One to be dextro, another one to be levo, another one to be levo. So this was counted as 1. This was counted as 1 because double bond is attached with same atom, so cannot show GI. This cycle of 4 membered can't show GI, so this is dead for GI. You know very well, cycle up to 7 membered cannot show GI, so this is counted as 1. But here we are going to count it 2, so the answer is coming out. Your answer will come out what? Answer is 4. Answer is 4. So everyone got failed? Everyone got failed or not? Do let me know, everyone got failed or not? So if they have asked only structural isomers, then the answer would have been 3. If their question was only structural isomers, then the answer would have been 3. But they have asked C, including stereoisomers, so we have to write down the answer of this question is 4. It's really fantastic question. Got it, kids? Everyone is able to understand. Show me green hearts if you got it, kids. If you got it, really got it. Chiral means the carbon attached with 4 different atoms or groups. Kids, those who don't know isomerism, then how will you be able to understand? You won't be able to understand if you don't know isomerism, kids. If you don't know isomerism, you won't be able to understand. Now see, kids, I think this point is clear to each and everyone. This point is clear to each and everyone, kids. Now let me move towards this reaction. Well-known reaction, kids, you know, our soda-lime reaction. Now, soda-lime reaction is what? The soda-lime reaction will come in the preparation of alkanes from what? Preparation of alkane from carboxylic acid. This is under the category of preparation of alkanes from carboxylic acid. So I would like to say this will come under the category of preparation of alkanes from carboxylic acid, RCOOH. Now simply if I say what is soda-lime reaction, kids, then soda-lime reaction RC double bond OOH. And just see to it, if I react it with sodium hydroxide NaOH in the presence of catalyst CaO, quicklime, then just remember that the CO2 will get released. The CO2 will eliminate out, kids. The CO2 will get eliminated out, and we will get the product as what will left behind, kids. Just see, this will get eliminated out, and this R carbanion will be there. Carbanion will be there, and this proton, they will combine together and they will release this carbon dioxide. This will get eliminated out, and your product will be RH hydrocarbon, and the CO2 is acidic. The CO2 is non-metal oxide gets non-metal oxide plus basic oxide, basic hydroxide. The acid and base will combine together. These two will combine together. They will form what, kids? They will form sodium carbonate. They will form sodium carbonate. I hope that you are able to understand. So this will be the Y product, and this shortening of chain by one carbon will take place. Shortening of chain. Kids, my content is a little bit tougher, but this time paper will also be there on the tougher side. Remember that, and you have to prepare for that, kids. I want to see your advice also, not the advice or the suggestion, whatever you want to say, kids. Do let me know in the chat section, because the last time, last year, okay, you won't break. Okay. So let's have a break. Okay, let's see what time right now. What's the time, kids? Let's see what's the time right now. It's 8:11. So break, let's take break. Everyone is in need of break, kids. No problem. So let's keep it for, let's meet at 8:30. Okay, 8:35. Is it clear, kids? Is it fine? Okay, is it fine, kids? Do let me know. Okay, kids. Yeah, it's dinner break. Kids, you do your dinner. It's a dinner break. You just have it. It's a dinner break, kids. Okay? Then don't ask for the break, kids. Kids, number of people, they do dinner at this time only. So, it's a dinner break, kids. Okay? Okay? Let's meet at 8:35. Okay, kids? Welcome back again, kids. Are you ready? Is everyone ready, kids? How is the Josh? Just to let me know how is the Josh, kids. Let me check it out. That is everyone ready after the break with full on Josh? Wow, that's really awesome, really awesome. I can see that kids are back. Beyond time, beyond time, beyond time. Saucy, Namrata, Madhu, everyone. That's really fantastic. I can see that everyone is back. So let's go. Let's move on. Let's move here. Let's move here, kids. So I'm telling you soda-lime reaction. What I'm telling you, kids? Soda-lime reaction. What do you mean by soda and what do you mean by lime? And how the things are getting converted. If I say that I'm being provided with CH3, C double bond O, OH. And if I am reacting, kids, this with NaOH, in presence of calcium oxide. Now see, my dear friends, NaOH is soda and this calcium oxide, why they are using, this is actually deliquescent in nature and that is hygroscopic in nature. That's why it is acting as a catalyst. Now what I've told you, just remove this and you will get product. Remove it from here. Remove it from here. Now what you will get, kids? Do let me know what you are going to get. This CH3 negative and this H plus, they will club together. They will club together and the CO2 will go and form a bond with NaOH. So it will get eliminated out at Na2CO3 and this hydrogen will come and join this carbon. So what I'm talking about, kids, that if your carboxylic acid of two carbon atoms, then the hydrocarbon will contain one carbon less. You will get one carbon less hydrocarbon. Now if I say, kids, if I use this carboxylic acid like this CH3, CH2, C double bond O, OH, then I will remove this carbon dioxide, and this carbanion and this proton will combine together. And can you please let me know what you will get? You will get CH3, you will get ethane gas and Na2CO3 will eliminate it out. Now you see just over here, the reactant is having 3 carbon atoms. Can you see? It is having 3 carbon atoms. What one carbon got decreased, you got alkane, that is being ethane with 1 carbon less. So if you want to prepare hydrocarbon which is having 1 carbon less as the product, that is shortening of the chain. Kids, everyone is able to understand. Do let me know. Wow, thank you, Saucy, thank you. Now, if anyone is asking that you are provided with benzoic acid, if you are provided with benzoic acid, now my dear friends, if you are doing soda-lime reaction, that you are reacting with NaOH and calcium oxide, so you see that carbon dioxide will get eliminated out. It will get a negative charge and this proton will form bond with this. Now what you are going to get? Your product will be benzene. Now if anyone is giving you phthalic acid is this compound. This compound is known as phthalic acid. Now here P is silent. This is your phthalic acid. Now my dear friends, if you are going to react it with NaOH and calcium oxide, now see, 2 carbon dioxides will get eliminated out, my dear friends. So 2 negative charges and these 2 protons They will come over here and they will once again they are going to form what? Benzene. Now if you are having another compound, my dear students, suppose if they have given you salicylic acid, this is your OH, COOH. Now they have given the same reaction NaOH in presence of quicklime. Now what you're supposed to do, kids, you have to remove this carbon dioxide and you will get product as phenol or sodium phenoxide. Both you will get. Now my dear students, I hope that you are able to understand Na2CO3. Till now I haven't told you the mechanism, but I want to know that this is basic, but the basic is clear, kids. The basic is clear to all of you. If the basic is clear, then I will tell you the mechanism, then I will tell you the number of questions. I will move step by step. Kids, I will go step by step. Everyone is able to understand. Now see, if anyone is going to give you a question like this, butanoic acid suppose, or pentanoic acid, they have given like this. Now if they are asking that soda lime reaction, we are going to deal with soda lime reaction, that is NaOH and quicklime they have reacted with. Now what should be your answer? Do let me know, kids. Just you have to remove this carbon dioxide. So it was an acid of how many carbon atoms? 5 carbon atoms. You will get alkane of 4 carbon atoms. CH3, CH2, CH2, CH3 minus Na2CO3, sodium carbonate. So shortening of the chain. I hope that everyone has got it. Now my dear students, because every time carbon dioxide is eliminating out, every time you are seeing that, who is eliminating out, kids? Who is being eliminating out? Do let me know who is being eliminating out. Carbon dioxide. That's why this reaction's another name is decarboxylation. It is also known as decarboxylation. Everyone say along with me, decarboxylation. What is the another name of it? Another name is lab method preparation of alkane. It is also known as lab method preparation of alkane. This is also known as, kids, lab method preparation of alkane. And my dear students, more than this, all these things are used for shortening of the chain. Shortening of the chain during conversion. If they are asking what is the use, then we will say this process is used for shortening of the chain by one carbon, because you are getting product with one carbon less. All these are the names. Now my dear students, let me move one step ahead. That if you are provided with RCOH and they are using NaOH, you know very well that this is being acid and this is being base. Acid base neutralization will take place, and from here the water will eliminate out. Who will eliminate out? Water will eliminate out. Once the water has eliminated out, you got Rexona or COONA, sodium salt of carboxylic acid. This was carboxylic acid. This is sodium salt of carboxylic acid. Now once again, you can react NaOH and calcium oxide. Then you will get RH plus sodium carbonate, Na2CO3. So whether carboxylic acid is given or sodium salt of carbonic acid is provided, carboxylic acid, sodium salt of carboxylic acid is provided, whatever is provided, your product will be same. Kids, are you getting my point? If you got this thing, Then let me give you one question. See to it, whether they are giving you benzoic acid or they are giving you sodium benzoate, and they are asking for do the soda lime reaction, that is decarboxylation reaction. My dear friends, can you tell me what should be the product in both the two cases? Do you think that the product will be same or different? This is sodium benzoate. It is used for preparation of pickles. Sodium benzoate, kids, remember that it's used in making pickles. Preservatives. It is used as preservatives. So in both the two cases, result will remain same, and that will come out benzene as the product plus sodium carbonate as the byproduct. Is it clear, kids? Then I will give you a little bit tougher part, little bit tough questions. If this much is clear, kids. Saucy present, yeah, Sahana present, everyone, you are getting it. Now everyone, everything is clear. You are able to understand each and everything, kids. Do let me know. Is everyone able to understand each and everything? Now, my dear friends, see. Let me tell you that whenever we are going to deal with RC double bond O, OH. Now, the mechanism is that it is going to form carbanion. It is going to form carbanion. Now, my dear students, I know very well that you have not studied GOC. So, my duty is to tell you which carbanion is more stable, okay? I will let you know. I know that you don't know GOC, right, kids? So, see, rate of this reaction, rate of decarboxylation, kids, is directly proportional to stability of carbanion. Stability of carbanion, and stability of carbanion you don't know, kids. So my duty is to tell you this stability of carbanion first, and then I will give you questions. First I will explain with the help of example, and then I will give you questions, kids, right? Now my duty is that whenever you see any carbanion like this, C double bond O, C H double bond C, the resonance, there is resonance, or you can say any carbanion like this, see, kids, like this. So double bond, single bond, double bond, this carbanion is stabilized by resonance. What to see? Pi, sigma, negative charge, anything like this, X double bond Y, single bond Z, there is negative charge, there will be resonance, kids. Otherwise, normal carbanions, 1 degree carbanion, this is 1 degree carbanion, then 2 degree carbanion. How to find out 2 degree? The carbanion, carbon attached with 2 more carbons, 2 degree, this is 1 degree, 1 degree, this is 2 degree, kids, 2 degree. Now if I draw 3 degree carbanion, then the carbanion, the carbon which is having negative charge, further attached with 3 more carbons, that is 3 degree. So the stability order will be like this. The carbanion which is stabilized by resonance is more stable, then 1 degree, then 2 degree, then 3 degree. Then only I will give you question. I know, kids, you don't know GOC. I'm not talking about everyone, but few students, they don't know GOC. So it's my duty, it's Baba's duty to tell you what is resonance. Once again, let me tell you on the next page, kids. Those who are unable to understand, I can understand, kids, that maximum students, they don't know what is resonance. What I'm telling you, kids, any non-metal X double bond Y, single bond Z, just adjacent to this, just adjacent to pi bond if there is negative charge. What I'm saying? In between two atoms, adjacent carbon is having negative charge. This will do resonance. I will say it is resonance stabilized. It will do resonance. If resonance is there, then the carbon ion becomes highly stable. So let me give you example. Let me give you example, kids. Don't worry. So if I say that there is C double bond O, or I can write like this, C double bond O, and there is carbon which is having negative charge. So this will do resonance with this. This pi electron will do resonance with this. That means it is highly stable. It is doing resonance. Kids, are you getting my point? Now, let me give you example of this. That if I say the compound is given like this, CH3, C double bond O, CH2, C double bond O, OH. Now, my dear students, I have told you that wherever the COH is located, this COH is located, trace this COH, it is located over here, kids. It will eliminate out like this. The adjacent carbon will take electron from that carbon, it will develop negative charge. Now see, X double bond Y, single bond Z. This is pi bond, then sigma bond, and adjacent carbon means in between these two carbons, this is having pi bond, and there is pi electron. They will do resonance. Are you getting my point, kids? That here the resonance is taking place, stabilized by resonance, stabilized by resonance. So it will do resonance. So its decarboxylation will take place very easily. So decarboxylation is taking place. What you will get? This compound as a whole, CH3, C double bond O, and this CH2 will get one hydrogen. So this product we will get, kids. If you're not able to understand resonance, I know that GOC you don't know, but I am telling you, then only I can frame out tough question. Kids, are you getting it? I know that GOC you don't know, kids, but do let me know, kids. Kiran Pathak just have class of it. I can't tell you up to what time this class will take place. Kiran, please, kids, please do let me know the resonance you are getting, because I know that resonance, you don't know anything about resonance. So it's my duty to tell you, no, it's only up to 12 or 1, not up to 5 and like that. It's small chapter. If resonance is clear, do let me know, kids. Very good, kids. Now see, now if you understand this much, then see, let me show you the resonance stability, and then you can understand. So what I'm telling you, kids, that if any compound you will get like this R, C double bond O, and C negative, this is stabilized by resonance, stabilized by resonance, right? This carbon ion is stabilized by resonance. Then I will write this carbon ion 1 degree. This is also 1 degree. Just see, kids, CH3, CH2 negative. Remember that the carbon having negative charge is not attached with any carbon is also 1 degree, or the carbon which is having negative charge is attached with one carbon. Both are 1 degree. One is super 1 degree, one is just 1 degree. After 1 degree, I will come to that CH3, CH negative, CH3, and at the last, the carbon ion will come 3 degree. This is a least stable. Now, kids, once I have told you this much, Now my duty is to give you question. So after this, are you ready for the question? That carbon ion stability matters a lot. The one whose carbon ion is more stable is going to show decarboxylation easily. Stability of carbon ion. This is the order for stability of carbon ion, kids. Carbon ion. Now are you ready for the question? Rate of reaction is directly proportional to the stability of carbon ion, but if you are ready, then only Baba is going to give you question. Now kids, see how the question will be asked in your examination. Arrange the following in decreasing order of, the sign means decreasing order of rate of decarboxylation. Rate of decarboxylation. Are you ready, kids? Let's see. One example is given like this: A CH3 CH2 C double bond O CH2 COOH. Second example is given like this: CH3 CH2 COOH. Another example is given like this: CH3 CH3 COOH. And the last example, D1, is given like this: CH3 whole thrice C COOH. Now kids, what's your answer? What's your answer? Let me check it out. What you are going to give the answer, kids? Let me see in the chat section what answer you are going for, kids. 1, 2, 3, 4. 1, 2, 3, 4. Exactly correct. Rakesh, South Sea HSPN. Okay, Kiranji. Okay, that's fantastic. Now see, kids, just see to it. If it is going to break the bond from here, if it is going to break the bond from here, kids, then you see the carbon ion will develop at this place. The carbon ion, it will get charge at this place, and this will do resonance. Or you can simply say, one more trick is there. COH group is there. This carbon is alpha and this is beta. Whenever you see beta keto carboxylic acid, beta keto carboxylic acid, if you see beta carboxylic acid, beta keto carboxylic acid, then definitely it will do with high speed decarboxylation, maximum speed of decarboxylation, maximum speed. Now as you see, this is going to be 1 degree carbon ion, this is going to be 2 degree carbon ion, and this is going to be 3 degree carbon ion. So maximum rate A, then B, then C, then D. Now kids, you got it. This is the rate of decarboxylation, rate of decarboxylation reaction, rate of decarboxylation. Kids, got it? First point is clear, first question is clear, then I will give you another question. If this is being clear to each and everyone, let's see the second question. Second question is like this, kids. A is CH3 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 COOH. B is like this: CH triple bond C COOH. Third one, C1 is CH2 double bond CHCOOH, and the D1 is like this, C double bond O COOH. Now let's see what's the answer this time, kids. Let's see, are you going to win this race? This time you are going to get the correct answer or not, kids? Do let me know. What's your answer, kids, this time? Stella, no problem, no problem. Baba is here to teach you, kids. I will teach each and everything. I will make you perfect, kids. Baba's Jyoti Jain is going DCBA. DC. Okay. Kids, let me tell you what should be the correct answer. Let's see. Baba will make you understand each and everything. Just see this compound. COOH. Where COH? Just adjacent carbon is alpha carbon. This is beta, that is also beta. Can you see this is beta keto acid? This is being beta keto acid, kids. This is beta keto acid, means stabilized by resonance. Am I right? This is stabilized by resonance or not, kids? SBR means stabilized by resonance. Now see, this carbon is sp2 hybridized. sp2 hybridized electronegativity is 2.75, and this carbon is sp hybridized, its electronegativity is 3.25. Now remember that if you're going to get negative charge, my dear friends, if you're going to get negative charge, I would like to tell you one thing, that remember that negative charge is more stable. Negative charge is more stable on more electronegative atom. If the size is same, more stable on more electronegative atom. When the size is same, who is maximum electronegative? So this is sp3 hybridized. This carbon's electronegativity is just 2.5. So kids, this is 2.75, that is 3.25, and this is 2.5. If you don't know, let me tell you, my dear students, let me tell you, if you don't know this point, let me tell you one thing. Remember, always remember that, kids, it's my duty to tell you, those who are unable to understand, if there is sp3 hybridized carbon, sp3 hybridized carbon's electronegativity is 2.5. sp2 hybridized electronegativity is what? sp2 hybridized is 2.75, and whenever you see sp hybridized carbon, kids, its electronegativity is 3.25. The difference is like this. More the S character, more is the electronegativity. Always remember that. What point I am saying? More the S character, more the percentage of S character, more the percentage of S character, more is the electronegativity. More will be electronegativity, kids. Electronegativity. Got it? And negative charge is more stable on more electronegative carbons. So let's come back. Let's come back, kids. So this is stabilized by resonance. So it is going to be on number 1. So D will come on the number 1. After D, this is more stable. This negative charge will be more stable, kids. D, then B. It will be B. After B, C. D, B, C, A. Kids, agreed or not with me? This is the rate of decarboxylation. I want to see in the chat section, agreed or not? Are you agreed or not? Dholakpur Kalia, DBCH, Bhumika, very good, very good. Hafiz, you have come. Fantastic, Hafiz. Do let me know, kids, you got it or not. I want to see the green hearts, kids. If you got it, really, if you got it. I want to see green hearts, kids, if you really got it. Everyone, Jyoti Jain, very good. Fantastic, fantastic, kids, you got it, got it, got it. Now, once this is clear, now I'm going to give you one more question. Green hearts, fantastic, fantastic, kids, fantastic. Now see another question on your screen, just see to it, kids. If I give you one question like this, this is A, CH3, CH2, CH2, C double bond O, CH2, COOH. Now there is another B, CH3, CH2, COOH. Now another one C, CH3, C2H5, CH3, COOH. Now one is there D, CH triple bond CCOOH. Now what's the answer, kids? What will be your answer? I want to see your answer, kids. This time you are going to fail or to get passed. Let me check it out. Kids. Do let me know. You are going to get failed or passed. Nitesh, Varan, AD, Rakesh, ADBC, ADBC. I think the start is very good. A, just if I focus on A, this is negative charge and it will do resonance. So stabilized by resonance. Either you can see like this, or you can say this is alpha carbon, this is beta. So this is beta keto acid, and beta keto acids will undergo decarboxylation with maximum speed. So A is correct. After A, you see this carbon's electronegativity is 3.25 because sp hybridized. So D, after A it is D. Then after D, this is going to be 1 degree carbon ion, and this is going to be 3 degrees. So it will lie as last ADBC. Absolutely correct answer. Absolutely. So congratulations. So everyone is able to understand decarboxylation. So at the last, let me tell you one point. Kids. What's that? There is one note. Remember that beta keto acids, beta keto acids undergoes decarboxylation, simply on heating, kids. Simply on heating. Now what's the reason, kids? What I'm telling you, the reason is that their carbon ion is so much resonance stabilized that simply on heating they will undergo decarboxylation. There is no need of even soda lime reaction. The reason, assertion and reasoning, the question is going to come. Then the reason is there they have carbon ion which is stabilized by resonance, and this is the reason, right? Now if they are asking the question, kids, like this, that which question is which compound will show fast decarboxylation simply on heating. A option, CH3COOH, they can give you name of its acetic acid. B, oxalic acid, or they can give you CH3CH2COOH. They can give you CH3 C double bond O CH2COOH, and they can give you benzoic acid. So out of these four, what's your answer, kids? What answer you will give? Simply like this. These are the four. Out of these four, what's your answer, kids? Do let me know in the chat section. Everyone just do let me know the answer. What answer you are going to mark for? Everyone do let me know, kids. Fast, kids, fast. C, very good. C is going to be the correct answer. Fantastic. Because you got it that C is being beta keto acid. This is alpha and this is beta. Beta keto acid. Now, my dear friends, decarboxylation is done and dusted. Now, from COOH, there is one more method. Do you remember what's that? It's known as Kolbe's electrolysis. The second method with COOH is known as Kolbe's electrolysis. Kids, are you ready for Kolbe's electrolysis? Kolbe's electrolysis. With one this, there is Kolbe's electrolysis. I want to see that everyone is ready, kids. What I am saying, Kolbe's electrolysis. Baba is going to deal with Kolbe's electrolysis. Preparation of this from Kolbe's electrolysis. Kolbe's electrolysis. Kolbe's electrolysis, kids. Kolbe's electrolysis. Right? Are you ready for this, kids? Is everyone ready? Kolbe's electrolysis, I will give you the trick also. Baba will give you the trick also, kids, for Kolbe's electrolysis. Are you ready, kids? Now see, just see. Whenever you are going to take RCOONA aqueous, or you take RCOOK aqueous, what they will write in the theory? They will write sodium or potassium aqueous salt of carboxylic acid. What they will say kids? Sodium or potassium, aqueous salts of carboxylic acid. And in this electrolysis, because this is also prepared from carboxylic acid, kids. From carboxylic acids, we are having two methods. One is soda-lime reaction, another one is Kolbe's electrolysis, right, kids? This is also the preparation of alkane from carboxylic acid, RCOH, and under this category only we are going to deal with. Now see, kids, when you supply current, they can even write I for current, then what you will get, kids? Number of things you will get. At anode. They will ask about anode, what you will get. They will ask at cathode what you will get, kids. So they will ask each and everything. They will ask about anode what you will get. They will ask at cathode what you will get. So are you ready, kids? Is everyone ready? So Baba is going to tell you, kids, you have to stay with me. First promise, make a promise that, kids, I'm going to give you quality content. Otherwise, I would have completed alkane in 4 hours only, 2 hours only, 3 hours only, even 1 hour only. But let me see in the chat section, kids. Will you stay with me, kids? Everyone, do let me know how many of you are saying, kids, that you will stay, that only Baba is going to give the quality content, kids. Make a promise. Baba is giving you quality content, kids. Then you have to make a promise that yes, you are there. Sausi, yes. Rochna Shri. Madhumita, wow, yes. Fantastic. Rohini, Manoj, Swavsi, Jai Bhumika. Wow. Nesha, Param. Yes. Haricharan. Now Fall, Badvita will stay, and Baba Niranjan. Wow. Yaya, Chandrika, Namita, Madhu, Nivra, Naveen, Kirthana, Hafiz, Sahana. Promise, Nitesh, Varun. Wow. Yes. Narayan. Now Baba is feeling good. Harish Bala, Vidhi Yadav, wow. Dar, kids, wow. Everyone, wow. Now, kids, this is the way. This I need, kids. Then only Baba can explain. Now, for the Kolbe's electrolysis, first I will give you the trick and then I will explain in detail, right? Or first you want in detail and then I should give you the trick. What you want first? Kids? Detail. If you want detail first, then you have to show me green hearts. In detail first, then show me green hearts. If you need short trick first, I will give you both. Short trick first, then you have to show me fire. What you want first? The one who is going to win this, I will move like that. Let me see, the green hearts are more or the what is more? Kids, let me see. What is more? Oh my God, kids, you are superb. Detail first. Oh, this is the best trick, kids. This is the awesome thing. Oh my God. That's fantastic. I got it. In detail first. First in detail. Now see. If I say, my dear friends, that I'm having a chamber, electrolytic tank. Let's take electrolytic tank. This is the electrolytic tank. Okay. Let me put here anode and cathode. This is anode. Let's suppose this is anode and this is cathode. So who is going to be anode and who is going to be cathode? Who will decide? The battery will decide that who is going to be anode and who is going to be cathode, kids, right? Who is going to decide? The battery will decide the one who is anode or who is going to be cathode, right? Now see, the one who is attached to the positive terminal of the battery is known as anode, and the one who is attached with negative terminal of the battery is known as cathode. So it's opposite to, remember that it is opposite to electrochemical cell. This is electrolytic cell, electrolysis we are doing. So anode is positive terminal, remember that. the anode is positive terminal and cathode is negative terminal, right? Cathode is negative terminal. Okay. Now, my dear students, whatever the cell is there, always oxidation takes place at anode. At anode, always oxidation takes place. Oxidation place. This is oxidation place, and that is the place where reduction is going to take place. Reduction will take place. Now, my dear students, what do you mean by oxidation? Simply, the oxidation means loss of electrons. Loss of electrons. And reduction means what? Gain of electrons. I hope that this much is clear. Gain of electrons. Now, what is the electrolyte? The electrolyte over here is gets. Who is the electrolyte? Let's see. The electrolyte is RCOO negative, and because they are placed in water, so water, you can say delta positive and OH negative. So I can write down OH del negative, H del positive, and Na positive. So two types of cations and two types of anions are there. So both the anions will move towards what? Both the anions will move towards anode. Once the electricity is passed, both the anions will move towards anode, and both the cations will move towards cathode. But now, who will get preference? That matters a lot. Both the two cations will move towards cathode. Remember that. So how will you? One thing is the point to understand, another thing is to cram it. That anions towards anode. Remember that this is the cramming part. Anions will move towards A for anions, A for anode. Anions will go towards anode. Anions will go towards anode, and cations will go towards cathode. This is the trick. Cations will go towards cathode. I hope that you are able to understand. Anion towards anode, cation towards cathode. But remember that this will get preference. The carboxylate ion will get preference, and if it is getting preference, then 2 moles of this, they are going to lose electrons. So it will undergo oxidation. So it will become RC double bond O, O free radical plus 2 electrons negative. This much will happen, 2 electrons. It will give 2 electrons, and you know that standard reduction potential of H plus is more. The H plus SRP. What do you mean by SRP? The tendency to undergo reduction of H plus is more. So twice of H plus will take 2 electrons and it will form hydrogen gas. So hydrogen gas will get released at cathode. Now what is going to happen at anode? Just see, this carbon dioxide will get free. This carbon dioxide will get free, and R free radical will formed, and 2 moles. So 2 moles of R free radicals and twice of CO2 will get released. So 2 moles of CO2 will get released at anode. Hydrogen gas will released at cathode. Now this R, what this R can do? Here the space is less. So let me take another page to explain what this R will do, right? What this R is going to do. The first thing is that, let me tell you over here only, R will combine with another R to form RR alkane. RR alkane gas. RR alkane gas. 1 mole of carbon dioxide we have got at anode. RR we have got at anode. That 3 moles of gas we have got at anode. 1 mole of alkane, 2 mole of carbon dioxide, right? Now what other things it can do, I will tell you on another page. What is left behind? This OH is left behind and Na plus is left behind. So we will get NaOH in the solution. As the reaction is going to get progress, it is progressing, the NaOH amount will increase. that OH amount will keep on increasing, so pH of the solution will also keep on increasing. Till now you got it. I will tell you the traces, the negligible amount, what is going to happen, but till now this is clear. If clear, I want to see in the chat section till now. Medico, wow. Kids, do let me know till now. Till now, is it clear, kids? Everyone do let me know till now, is it clear? If yes, I want to see green hearts. Everyone just do let me know till now, is it clear? Wow, Saucy, thank you. Thank you, Saucy. Perfect. Okay. Now we will see what is going to happen. Kushiga, Manojan, very good. Right now we cannot give the break, kids. I have to teach. Now, the things which are happening in traces. Let's see what is happening in traces. In traces, just see, I can say the R and R, they can undergo disproportionation. How they will undergo disproportionation, I will tell you with the help of one example. And another thing, second part, what can happen, just see, the RC double bond O, we got RC double bond O and O free radical. This free radical can combine with R free radical. That free radical can combine with this to give ester. Ester will be in traces. These two parts will be in traces. Now let me explain how. Kids. Suppose, kids, you got this compound. CH3, CH2, COOK aqueous, and the current is supplied. Now you know that what is going to happen. This will break. You will get CH3, CH2, COO negative. Now it will undergo oxidation. Kids. Now if it is undergoing oxidation, you will get CH3, CH2, C double bond O, O free radical you will get. You got. Now this will break from here and you will get CH3, CH2, free radical you will get. Now the maximum product, major product, what you are going to get? The major product is that 2 moles of this will combine. 2 moles of this will combine to form butane, kids. These 2 moles will combine and they will form butane gas. This is going to be the major product, kids, right? This is definitely going to be the major product, right? At anode, we will get 2 moles of carbon dioxide at anode. That is also going to be a major product. But traces, if you want to find out what is going to happen in traces, disproportionation, I'm going to tell you disproportionation, that CH2H and this CH2 free radical, then another molecule of this CH3, CH2, just see, kids, what is going to happen. This compound will break from here and it will lose this hydrogen. This hydrogen will go away from this. Now this will turn out to be, it will get converted into CH2, this free radical and this free radical, they will combine to form ethylene gas, which is used for artificial ripening of the fruit, and this will come over here. So it will convert into CH3 and CH3. My dear student, this is the detailed. Now, it's looking idiappa muruku. To make it nalla iruku, romba sulvam, we need a short trick. We want some short trick. How many of you are in need of short trick for this? Just to let me know. How many of you want the short trick for this? Kids, do let me know. Then Baba is going to give you the short trick for this. I'm going to make it romba sulvam. See, Baba HSP's short trick, fantastic short trick. Just see everyone. Baba HSP's short trick. See everyone, see to it. I will take CH3, CH2, C double bond O, OK, one more molecule of this, CH3, CH2, C double bond O, OK. Now water, I will take water, HOH, HOH. Now see, we will supply current. Now see, focus over here. Everyone, focus over here. Just see, focus over here at this place. Everyone focus. I need your focus, kids. Just see what Baba is going to do. Everyone, just see. This will break from here. 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 Right? It is going to break from here, kids. Just see to it. Hey, this is going to break from here and it will form a bond at this place. Just see. It will form a bond with this one and it will break from there. Now it is breaking. What this will form? What this will form? This will convert into CH3, CH2, CH2, CH3. We got butane, normal butane. Now it has broken. It has broken down from here. We will get CO2. We will get CO2. Remember that. A, B, C. If you apply, if you know how to drive car, accelerator, brake, clutch, A, B, C. At this place we are having A, that is anode, B the solution, and C the cathode. Anode, basic solution, cathode, A, B, C. Now you are getting 2 moles of carbon dioxide. All these things we are getting at anode. I hope that you got it. That 1 mole of butane, 2 mole, that 3 moles of gases, 3 moles of gases we are getting at anode. It is clear. Now see, this is OH negative and that is H delta positive. What we are getting at cathode, do let me know. That we are getting hydrogen gas at cathode. We are getting hydrogen gas at cathode. 1 mole of hydrogen gas at cathode. Now what is left within the solution? Just see what is left within the solution. The KOH and the KOH, that 2 moles of KOH we are getting in the solution. That means the pH will keep on increasing. pH will keep on increasing. pH will continuously increase. Got it? Are you able to understand the short trick, kids? Do let me know. Kids, how is the short trick? Everyone do let me know. My dear students, Do let me know how is the short trick. If it is clear, I will give you one question and then we will come to know that you are able to understand it or not. First of all, everyone do let me know how is the short trick. Everyone do let me know. Sausi got it. Sausi got it. Amazing explanation. Wow. Nitishan, Sulbham, Parama, very good. Now, if it is clear, kids. Wow, kids. Wow, that's fantastic. I will let you know, Hariwala, I will let you know. Now see, kids. Now see, I'm going to give you one question. If this is clear to each and everyone, so take one question and see whether you are able to do it in this way or not. The question is, super awesome question, that CH3 COONA aqueous is reacted with current, is allowed to undergo electrolysis, what products you will get? This is your reaction. You have to find out what answer you will get. You just apply your brain. Everyone apply your brain. Then Baba is going to tell you. First you apply your brain. Then I am going to tell you. So see, Baba is solving it. You can see my solution. You can go with your solution. At all your choice. That depends on you, kids. I have taken one molecule. Let me take another molecule of it. I will take water, HOH. Now I want to become superb. Let's see whether I'll be able to become superb or not, kids. Let's see to it. That I would like to break this bond. This bond is going to break from here. It is going to break from here and it will form one new bond at this place. This is coming my alkane. If this is your alkane too, then it's really fantastic. So Baba is going to get this alkane as the answer. 1, 2, 3 and 4. 1, 2, 3 and 4. 1, 2, 3, 4. 1, 2, 3, 4. This is the alkane. I got 2 moles of carbon dioxide. This all I got at anode. In the solution, I got 2 moles of NaOH. And then I have got hydrogen gas at cathode. This I have got at cathode. ABC. This basic solution ABC. And this much I have got at anode. ABC. At anode I have got this much, kids. If you have also got the same thing, I want to see green hearts in the chat section that this is your answer also, kids. That means the trick is working. If you have also got the same answer, that means the trick 2,3-dimethylbutane. Wow, Rakesh, you're rocking. R for Rakesh, R for rocking. Everyone, do let me know that this is your answer also, kids. Is this your answer also, kids? Fantastic. That's really fantastic. Now, my dear students, we are able to understand Kolbe's electrolysis. Everyone is able to understand Kolbe's electrolysis. Now, kids, if anyone is going to give you question like this, they can give you even the question in this way also, kids. They can give you question like sodium butanoate. aqueous solution is treated with current, or they can write it's undergoing electrolysis, as allowed to undergo electrolysis, then what's your answer? What's your answer? Now what you are supposed to do, kids, just think for this. This was the question. How to find out answer of this question? Just apply your brain. Then I will tell you, then I will let you know. Just apply your brain, kids. Then my brain says I should know how to write down sodium butanoate. If I don't know how to write down sodium butanoate, I won't be able to do anything. Now kids, this is your sodium butanoate. Am I right? Yes sir, you are right. Absolutely correct. 1, 2, 3, 4. Now I will write one more molecule of it. The sodium butanoate, I will write like this. Now the aqueous solution I know very well, HOH. HOH, I have supplied current. Now for me it's very simple. I'm supposed to do only one thing. From where I'm supposed to break? I'm supposed to break it from here. I will form bond at this place. So what answer I'm going to get? CH3, CH2, CH2, and the new bond formed right now in between those two carbons. So CH2, CH2, CH3. This is hexane and this is liquid. Remember that this is being liquid. Hexane is liquid. Plus 2 moles of carbon dioxide at anode, plus 2 moles of NaOH in the solution. So the pH will keep on increasing. Plus 1 mole of hydrogen gas I will get. These are in the major amount. Really, you got it like this? If yes, everyone is rocking. I would like to say that the trick is working, kids. Everyone just to let me know. Everyone is getting. Now after this I will tell you rest of the things. Kids, everyone just to let me know that you are able to understand. O missing. Where O is missing? Yeah, thank you for helping me. Thank you. Here O is missing. Kids, really you are doing wonderful job. Now you got it. Everyone got it. I think that everyone is able to understand. Everyone is able to do it now, kids. After this, till now whatever I have told you, the preparation of alkane. In the preparation of alkane, first I have told you the hydrogenation. Second, I have told you from carboxylic acid. Now let me tell you the diagram, how I am moving and what I am telling you, kids. Let me tell you each and everything, that how Baba is moving, kids. I have started with preparation of alkane. I have started from preparation of alkane. Just see, let me tell you, I have started with preparation of alkane. This I have started, kids, right? Preparation of alkane. Now in the preparation of alkane, I've told you that what I am going to tell you, what I am going to teach, kids. In the preparation of alkane, the properties, the things, I've told you that I will go with 1, 2 and 3. Only 3 steps, 3 ways of preparation. One, that I've told you from what? That from carboxylation, that hydrogenation. I've told you from hydrogenation of unsaturated compounds, already explained. The second, I told you from carboxylic acid, from RCOH. In this category, I have told you 2 processes. What are these 2 processes? One, I have told you soda-lime reaction. Soda-lime reaction, always keep it in your brain. Soda-lime reaction. The second thing I have told you, Kolbe's electrolysis. Kolbe's electrolysis I have told you. Now my dear students, only in the preparation one is left, that the third one. This third one is from RX. Now how to prepare from Rx. Now under this category I will teach you kids that using LiAlH4, then I will tell you Wurtz reaction. After Wurtz reaction I will tell you Wurtz-Fittig reaction. Wurtz-Fittig reaction, then I will tell you Ullmann, then Franklin, and then Corehouse. So I have to tell you 3, 4, 5 reactions in this kids. This is the preparation of alkane. Are you ready? This is the flow chart. I think that you are getting it. Everyone, you can understand. Everyone, you can understand. Yeah, Sahana HSPN is asking that which is gas, how to find out. I will tell you this point. Up to 4 membered, they are gases. One question has come, how to find out they are gas or not. Let me tell you over here only. Because Sahana has asked the question. Sahana is very good student. You kids all are my dear students. So let me tell you this. Otherwise, I would have told you this thing in physical properties. But you have asked here only. So let me tell you. C1 to C4. They are gases. They are gases because it is required over here in Kolbe's electrolysis. They are gases. C6 to C17. They are liquids. They are liquids. And C18 and onwards, they are waxy solid to solid, waxy solid, and then solid. Now one thing is missing. One thing is missing. What is missing kids? C5. C5, then I will say neopentane is gas. Neopentane is gas. Rest of two are liquids. What are they? N-pentane and isopentane. They are what? Liquid. But you have asked, that's why I have told you. Otherwise, I would have told you these things in the physical properties. In the physical properties. Maximum branching. That's why I will tell you in the physical properties. Maximum branching. So maximum branching means less surface area, least surface area. So it is gas. I think Sahana, you got it. Sahana, you got it. Everyone kids, I would have told you this thing in the physical properties, but kids, because it is required in what? In your this Kolbe's electrolysis. So I think Sahana has asked, and that's why I have told you kids. No, in NCERT it's not given in liquids. Haribala, kids, Haribala is saying in NCERT C5 is written as liquid. You just go down a little bit, go down and read it. They have written that its one member is gas. Remember that it's gas. Okay kids? Okay, now let me come back. I think this is clear. So let's set go with Rx. Preparation with Rx. Ready kids? Preparation of alkane from Rx. I hope that everyone is ready. Rx, in the category of Rx, first I will say that Rx, where X can be halogen. What halogen? Either chloride, bromide, or iodide, but X should never be fluoride. Remember that when it is going to react with LiAlH4, dry ether, then what you are going to get kids? You will get RH. LiAlH4 is hydride donor. Hydride. What do you mean by hydride kids? It's H negative. Hydride donor kids. Remember that it is hydride donor. And RX, R is delta positive and X is delta negative, so H will come over here. Now, if you want to understand it in detail, I will tell you, but first let's do one or two simple questions, then I will tell you in detail. Suppose if they are giving compound like CH3, CH2, bromide, and they have given lithium aluminum hydride LiAlH4 dry ether, this they have given, then what you will say, kids, how to complete it? Br negative, carbon positive, just give one hydrogen to this CH3, CH2H, you will get ethane, right kids, you will get ethane. Suppose they have given question like CH3, CH2, CH2, Cl, and they have reacted with LaH. In the shortcut they will say lithium aluminum hydride, this is also the name, or they can give you it like this LiAlH4, it is a complex compound, they can give you like this. What you're supposed to do, kids, this is delta negative, this is delta positive, answer will be propane. CH3, CH2, CH3, propane gas. I hope that this is clear. It's clear? Now I will tell you in detail, but if this much is clear, then only I will tell you in detail. If this much is clear, show me green hearts that yes, it's simple, sir. It's simple. If this is looking simple, then only I will give you the mechanism. I will tell you in detail. If yes, kids, if yes, if your answer is yes, then only Baba is going to tell you in detail, kids. Do let me know, everyone. Right, clear. So see, it's clear. Fantastic, kids. See, now let me tell you from the beginning, the whole story from the beginning. Now kids, first let me put the heading so that the kids, those who are new, they can also understand. Let me put their heading so that everyone can get it, what's going on. Those who are new, they won't be able to understand what actually going on. From alkyl halide, what I'm going to write? From from alkyl halide, from alkyl halide. Okay, from alkyl halide. So from simple from alkyl halide. Is it visible, kids? So everyone can understand from alkyl halide. From alkyl halide we are dealing with from alkyl halide. So everyone can understand it, okay? Now see, kids. Now if I say in one city there was a lithium hydride, lithium was saying to everyone, I can't handle this H negative. Who is going to take this H negative? Please come and take this H negative with you. Take this H negative one with you. One day, one aluminium hydride, he has seen that somebody is saying that take my H negative. Aluminium was having, aluminium is like this, atomic number 13, 2, 8, 3. Mother has given 3 electrons in the valence shell and said, go and do business, whatever you want to do, that's your business, none of my business. So aluminium has done friendship with hydrogen, and hydrogen, they have shared electrons. So now aluminium is having just 6 electrons in the valence shell, and aluminium is seeking, he's stingy for electron. He's asking everyone, hey, I'm in need of money, I'm in need of electron, I need you. So he said, hey hydrogen, just come and live with me. He has opted for this hydride. He was thinking that its electron I will take. So he started living with that hydrogen 3 hydrogens of its own, and 1 hydrogen he has got from lithium. Now one day he told the whole story to mother. Mother said, "Hey aluminium, what you have done? You are very small. I've told you not to keep more than 3. I've told you not to keep more than 3. What you have done? Just for having money you are keeping 4? You won't be able to control. You won't be able to handle. Just see anyone and transfer 1 hydride along with electron to someone." Now in the neighborhood of this AlH4 negative, and lithium is like this, living happily after donating that. Now aluminium searched for Rx and he said, "Hey Rx, I'm unable to control this. Would you like to take this hydride?" R said, "Yeah, my X is always saying I will go, I will go, I will go, I wanna go. So after taking your hydride, I will say to my X, ni po 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 poda, and ingeva, ingeva, evdeva, evdeva, ingeva, imbdeva." So it will take this hydrogen and will form bond, and will form a bond, and it will say, "Hey X, you go away from my life." Now X negative will go, and this will combine with Li plus, so it will form LiX, happy ending in this way. This will form RH. I hope everyone is able to understand. This is the mechanism how this reaction has proceeded. You liked it? You liked it or not, kids? You liked it or not, kids? Do let me know. Everyone, just to let me know you got it or not. Kids, you got it or not? Everyone, you got it. South Sea, very good. Yes, Manoj Jan got it. Hey, O'Brien got it. Roman Rings, you got it. Brahma, God of Chemistry, thank you, kids. You are my future engineer and doctors. Manoj Jain, thank you. Madhumita, thank you. Teju, thank you. Now, from alkyl halide, I will tell you the Wurtz reaction. From alkyl halide, Baba is going to tell you Wurtz reaction. Are you ready for that? Wurtz reaction, kids? Is everyone ready for the Wurtz reaction? Not the Burj Khalifa. I am not saying Burj Khalifa. I am simply saying Wurtz reaction. Are you ready for the Wurtz reaction? Tenu ghumadu mein Burj Khalifa. Tenu Burj Khalifa. So, Burj Khalifa, Wurtz reaction. Everyone ready to understand this Wurtz reaction? Oh, Wurtz reaction. Why it's not coming, kids? Let's see. Yeah. Wurtz reaction. Right? Right, kids? Wurtz reaction. This is going to be the most important one. Number of questions they are going to ask based on this Wurtz reaction. Simply, if I say how this reaction will proceed, that's a simple thing. If I talk about simple Wurtz reaction, just see Rx, 2Rx, and there is sodium, twice of Na. Just see what is going to happen, kids. Da da da, ding 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 ding, dishak. Rara, rara plus twice of NaX. This is the simplest approach for a school level. This is the simplest approach. But remember that this Rx should be 1 degree or 2 degree, but never be never be 3 degree. Remember that it can be 1 degree or 2 degree, but can't be what? Can't be 3 degree. Remember that it should not be 3 degree. Now, in a school level, how it is going to be asked, just see if they are giving you question twice of CH3Cl, and that is reaction with twice of Na dry ether. Twice of Na dry ether. Dry ether is the polar aprotic solvent, PAS. So polar aprotic solvent. Dry ether is polar aprotic solvent. What is polar aprotic solvent? Which cannot donate proton, but polarity is there. The solvent which is polar but can't donate proton, polar aprotic solvent. So ethane is the smallest alkane. Remember that when I was a kid, I have studied only this much, plus twice of, this is twice of Na also, so we will get twice of NaCl. I have studied only this much. In the name of Wurtz reaction, in my school, my teacher has taught me only this much. In my school level, I was having only this much of knowledge, but Baba will tell you each and everything. Baba will let you know in detail. But before that, kids, do let me know if examiner is giving you question like this. Isopropyl chloride. He has given you question isopropyl chloride. And he has given their sodium, written sodium, dry ether. Now what answer you will give, kids? This has been asked, suppose in your examination, in your school examination. I'm not saying only NEET or JEE. In your school examination, I want to see the answer in the chat section. What answer you are going to write, kids? What answer you will write, kids? Do let me know in the chat section. Do let me know. What answer you are going to give, kids? So you should know, for this you should know what is isopropyl chloride. If you don't know what is isopropyl chloride, you won't be able to give the answer. To give the answer, you should know isopropyl chloride. So let's see. Answer. This is isopropyl chloride. Am I right, kids? Am I right, kids? This is isopropyl chloride. Now 1 more mole of isopropyl chloride I will take, and just I will club it. I will club it in the center twice of Na. Hey dear, just go, just go, da-da-da, you should go away. Now what you are going to get as the answer? CH3, CH3, and just the mirror image of it, CH3. If we know the IUPAC, we will write 1, 2, 1 randa mononale, 2, 3 dimethyl butane, 2, 3 dimethyl butane, la. Got it, kids? Got it? Everyone got it? Is it clear? Clear to each and everyone? Clear? Very good. Now see, kids. Now see, if the examiner is going to give you a question like this, if he has given the question like this, kids, what's your answer? Just see to it. Now suppose by chance he has given question like this. Tell me the answer. If you got question like this, sec butyl chloride, and he has written sodium diether, sodium diether. And he's asking what answer you're going to get. This is your question, kids. Do let me know. Before I write down the answer, before I move for the answer, I want to see answer from your side, kids. What answer you're going to get? Do let me know. So I should know, for the answer I should know what is secondary butyl chloride. So see, this CH3, CHCl, CH2, CH3. Remember that secondary carbon, chlorine is attached, sec butyl chloride. So I will write down the mirror image of this CH, CH3, CH2, CH3. Then I will club sodium over here, twice of Na, my dear students. So now what I'm going to do, just to let me know what Baba is going to do. Just I will remove this and club it. I will club it and I will get the answer. You are getting my point, kids? Are you getting my point, what I'm talking about? What answer I am going to get? CH3, CH, CH2, CH3, and the mirror image of it CH, CH2, CH3 and CH3. What do you call it, kids? So 1, 2, 3, 4, 5, 6. The IUPAC name will be 3, 4 dimethyl and hexane. Am I right, kids? Now let me check it out whether you are able to understand or not. Then I will increase a bit label up. I will increase a bit label up, but everyone. 3,4-dimethylhexane, Stella, wow, Rakesh. Kids, I think now the studious students and the hard-working students are there. Jyoti, Sahana. Kids, now I think only studious students are left. Wow, kids, Baba is happy to see this great performance. Really happy, kids, really happy. Now see, kids, I'm so happy now. With this happiness, let me show you one thing. One compound I am going to draw. Just try to understand. If they are giving, oh my God, it's so bulky. Hey Baba, so bulky. Now see, if they are going to give you a compound like this. Now they have attached one bromine over here, one bromine at this place, and they have written twice of Na, dry ether, kids. Now what answer you will say? Now see, it will remove from here, it will remove from here. How it will remove? Let me show you, kids, so that you can easily understand it. Already the bonds, they are formed over here. This bond is already existing, this bond. Now 2 Br, they are leaving. 2 bromide, they are leaving, kids. So I will tell you the mechanism later on, but they will break like this. Now form a free radical, then these two will try to join. These two will try to join like this, and they will form a bond. They will form a bond. I hope that everyone is able to understand. Then the compound will look like this, kids. The final product will be like this, this, and new bond, baby. New bond, baby, new bond. This is the new bond, kids. This is the new bond which is formed over here. Q-vein is the answer. Q-vein. Everyone understood, kids? Everyone understood Q-vein is going to be the answer. Q-vein is going to be the answer. Everyone, you got it? Kids, got it or not? Let me see, my dear student, what they are doing. What you are doing, kids? Everyone got it or not? Just to let me know, everyone got it or not? My dear students, everyone got it now. See it, yeah. Now, by chance, they have given you a question like this. By chance, they have given you a question like this, kids. Now, here they have written chlorine. Here they have written bromine. Now, two options they can give you. Once they can give you one equivalent only. If they are giving you one equivalent only, that means this is only one equivalent. Now, how will you proceed? How will you proceed? Then you have to make it like this. From one side, bromine remove. This bromine will go away from one side. Bond is breaking. Breaking. Bond breaking. Now this will go like this. And they will start forming bond. After some time, they will form bond like this. And this is going to be the product. Although this product is not stable, that much not stable. Why, kids? This is not stable. This is the product. It is bicyclo. And in bicyclo, there is 3-membered ring. But kids, you know that whenever sodium is present, sodium is very volatile, explosive type. It will say, hey, I will break your bonds. You won't be able to save yourself. So even this compound is not stable. This is unstable. Now the question arises, why this has been formed? Because this is highly unstable. This is even more unstable than that. This is highly unstable, kids. This is being highly unstable. This is being highly unstable. So bicyclo. But if they have not written about this, that is one equivalent. If they have not written it to be one equivalent, then see what you are going to get. If they have not written one equivalent, they have simply given, what is this? If they have simply given it like this, then see, kids, this is Br, this is Cl. We know that very well, that carbon, chlorine and carbon bromine, this bond is weaker. This is weaker bond. So what is going to happen, kids? If you supply twice of Na, dry ether, kids, what is going to happen? See, kids, the two molecules will come together. You muskuraye. Now they will come like this. One bromine, just come, just come. La la. They are a stronger bond. They will not break. These two bonds will break. So the bond is going to break. Tick. Now tick. Once the bond is going to break, now see what type of things you are going to get. You will get this one. You will get this one. Now just see, kids. This chlorine will remain intact. That chlorine will remain intact. Dintac. And this bond will get matured. Tick. Tung. The bonding has taken place. Now the product will be finally seen. How many steps I am showing you so that you can easily understand, kids. In how many steps I am making so that everyone should get it easily, kids, because you kids are having lot of respect for your Baba. So Baba will try to give you the best content in the best way. This is the product. This is the product. The green one is the final product, kids. And the reaction was moving on its way like this, and finally it has given like this, kids. You are able to understand this is the final product. You are able to understand. Let me see in the chats. Kids, if yes, you got it. Wow, Kiran, fantastic. Wow. Fantastic, Rakesh. Thank you kids, thank you. And kids, smash the like button. Hit the like button if you're new, kids. Fantastic, fantastic. Now, let me tell you the mechanism. Thank you, Saucy. Thank you, Wish. Thank you, kids. Thank you. Hafiz, thank you. Now, kids, just see to it. Now, let me tell you the mechanism, then I will tell you one thing, kids. First of all, see, the most important thing, what they will ask. The burning question they will ask. That one thing you should remember, that this process, which process? This process gets, this Wurtz reaction is used only for preparation of remember that what? Only for preparation of what? Only for preparation of what, kids? Only for preparation of symmetrical alkanes. Remember that, symmetrical alkanes. And it's not economical, and it's not economical, and it's not economical for preparation of unsymmetrical alkane. Preparation of, it is not economical for preparation of unsymmetrical alkane. Now, what they will give you in place of symmetrical alkane and unsymmetrical alkane, they can also give you, symmetrical alkane means even numbered carbons. They can give you like this, and here they can give you odd number carbons. They can give you like this, kids. Now, the question arises why and how, why they will not be using like this. Letting you know this, let me come to this point. Let me explain, kids. Let me explain. Wow, thank you, kids. Thank you everyone. Just see, if I say that if I'm supposed to prepare propane is my target. Now let's see how to prepare. Target, what is the target given to me? Somebody has given me target of preparing propane. So what I will take, kids, what I will consider for preparation of propane. So I will take these gases. I will take methyl halide, suppose methyl chloride and ethyl chloride. Now, kids, remember one thing very clearly, that whenever it is written 1, they have not written one equivalent. That means there are n number of molecules. Many molecules are there. When many molecules are there, kids, what they will do? Sodium is many molecules, dry ether, the solvent. These are many molecules. Now, what they will do, kids? This can combine itself to give ethane. Self-Wurtz reaction, it can combine with itself to give butane. And now, when they are combining together, that means this one and this one, they are combining. This will give methyl and this will give ethyl. Then we will get propane. Now, my dear students, all they are being gases. This is gas, this is gas, even this is gas. Once all they are being gases, can you separate gases immediately, exactly, economically, easily? Answer is no. If we would have been able to separate gases, then during COVID pandemic, we must have separated nitrogen and oxygen. We must have done separation of oxygen immediately, and then when if we are able to separate oxygen, then there would not be any scarcity of oxygen cylinders. You know, maximum people died because of the scarcity of oxygen cylinders that was not available in that much quantity. So separation of gases is very tough. It will require more money. Everyone is setting company to get money, not to invest too much money, kids. So it's very tough. So remember that separation of gases is a very tough process. Separation of gases is tough. So answer is that we can prepare this. We are able to prepare this. What it's tough to separate it out, and that's why it's not economical to prepare such type of alkanes. Concept is clear? Just to let me know in the chat section. Only studious students are left. The rest of people are not there, and I'm so happy that in my class only students, those who are really genuine person, they are there. Rest of others are not there. I'm really so happy, kids. I'm so happy. Now, kids, now Baba is going to tell you the mechanism, that how the things are getting formed. Thank you, Sausi, Stella, Real, Prigya. If I'm unable to say anyone's name, call anyone's name, kids, don't mind please, because I'm not able to see everyone's name, kids. Now see the mechanism. If I talk about mechanism, this reaction, there are two types of mechanisms. There are two types of mechanism. One is ionic mechanism, another one is free radical mechanism. Two types of mechanism are there, kids. Free radical mechanism and ionic mechanism. So one is ionic mechanism. Let's see ionic mechanism. I would like to say that Rx, 2 moles of Rx, they will go like this. R positive, 2 moles of R positive, R positive. Now sodium, what sodium is going to do? Sodium, 2 moles of sodium atoms, they will donate 2 electrons and they will convert into twice of Na positive, 2 electrons negative. So these 2 electrons, suppose these 2 electrons are taken by this R positive. R positive was having just 6 electrons. By getting 2 electrons, R positive will convert into R negative. This has converted into R negative. Now this R negative will combine with this R positive and they will form RARA. RR. Alkane you got. This is the ionic mechanism. But this mechanism is not given an idea about how ethene is getting formed, how alkene is getting formed. And that's why there was need of free radical mechanism. There was need of free radical mechanism. Now see, kids, once the free radical mechanism, and see both the ways are exactly correct. See, if I talk about RARA, 2 moles of Rx, they are going to break down. So they will get R plus. R plus, this is also possible, kids, that twice of sodium is converting into twice of Na plus, and it is giving 1 electron plus 1 electron, 2 electrons. Here 2 electrons, both the 2 electrons were taken by 1 R plus. Is it possible that one R should take 1 electron, another R should take 1 electron? This is also possible. Quite possible, kids. Isn't it? That 1 R is taking 2 electrons. or 1 electron is taken by 1 R. Both the two possibilities are there. In this way, this R will form free radical and that R will also form free radical. Now there are two ways in which these two R can combine. One is R and R can combine to form rara alkane, and another one I have told you they can undergo disproportionation. Then one will form alkene and another one will form alkane. I hope that this point is clear, because in the Kolbe's electrolysis I have explained it, already explained it. Kids, explained it or not? Just to let me know in the chat section. Everyone, do let me know. Everyone got it? Till now, is it clear, kids? Everyone is able to understand? Do let me know, kids. Now, kids, fantastic. I can see all students, they are able to understand, they are putting their best efforts. I'm so happy, kids, to see this. Yes, Stella, Rani, Vijayasri, Dr. Sri, got it, Tanuja, Jyoti Jan, Teju, Chandrika, wow, break, Srinithi, break. Kids, should I give you break right now or after some time, kids? Right now or after some time, kids? Tell me. Rakesh, this I have told you, disproportionation. In the disproportionation, this I taught you how alkene. Disproportionation. Okay, let me first complete this much. Then after 1 hour I will give break. After 1 hour, okay? After some time I will give break, okay? Kids, let me complete it. Let me first complete it, then I will give you break, kids. You are very good students. Okay? Okay? Okay, we will try to complete it early, because no need to waste time, kids. Okay? You are very good students. Now see, kids. Now suppose, kids, if they have given you question like this, that just find out the answer of this question. Let me see that are you able to do it or not. Let's see, kids. If they are giving you question like isopropyl chloride is reacting with ethyl chloride. Write down all possible products in the presence of Na and dry ether. Now they are asking for all possible type of product. Find out all possible type of products. This is their question, kids. This is their question. Now see how to do it, kids. How to do it. That one thing, isopropyl chloride. This was the question, kids. Now the solution to this question, kids. Just see to it. I will write isopropyl chloride CH3, CH, Cl, CH3. In front of this, I will write ethyl chloride CH2. Cl, CH3. One possibility is that this can combine with that. If this is going to combine with that, then chlorine and chlorine will eliminate out. What you are going to get? You will get CH3, CH3 and CH2, CH3. Now another thing, this is the cross one. This is the cross one you got. Now itself, it is going to combine itself. What you will get? CH3, the mirror image CH, CH3, the CH, CH3 and the CH3. If it is combining with itself, what do you get? CH2, CH3, CH2, CH3. This is possible. Now what you will get in traces? It will form free radical and that will also form free radical. Now see the two free radicals, just see in traces in minor amount what you are going to get. This is for rank deciding. Rank deciding means top 100 rank. A rank deciding question if they are going to ask, then we will ask in traces. Just see if CH3, CHCl, CH3 is going to lose this chloride and it's going to form free radical, you will get CH3 free radical. And this is the another one, CH3, CH2, Cl is going to lose chloride, you will get CH3, CH2 free radical. Now in the disproportionation, what is going to happen? Just see disproportionation. Everyone, very, very important. If this is undergoing to do disproportionation, then let me take another pen, and disproportionation, that CH2 free radical. Now the bond will break from here, this electron will break from here, and you will get CH2, this electron, they will form a bond. You will get CH2, double bond CH2. I hope that this ethene is clear. And this hydrogen has gone to another ethyl free radical. This ethyl free radical, it has taken this hydrogen. Now see what is going to happen. They will form a bond. Now why I am saying disproportionation? Carbon is losing electron. This is a losing electron. And the same carbon is gaining electron. Electron is lost by carbon as well as gained by, that's why disproportionation. So one ethene you got. I hope this ethene is clear. Now my dear friends, if this is undergoing disproportionation, how it will undergo disproportionation? Just see to it. CH2H, CH free radical, CH3. Are you able to understand? Just see to it. Now it is going to lose this electron. It is going to lose this electron and they will form a bond. You will get CH2 double bond CH. CH3, you will get this propene as the traces amount of product, propene, and another one will get this hydride, and the another molecule, after getting that hydride, hydrogen free radical, it will convert into like this, and this propane. So this ethene as the alkene we got, and this propene we have got another alkene. I hope these are in traces and due to disproportionation. If you got it, just show me some green hearts so that I can understand that this is clear. If not clear, in traces means less, very, very less amount. Traces means in very, very less amount. Traces means in very, very less amount, kids. Traces means in very, very less amount, kids. You are getting my point? Traces means in very, very small amount. Very, very small amount, kids. You got it? Everyone is able to get it or not, kids? Do let me know. No, don't use moisture, because if you are going to use moisture, sodium will explode. Sodium is very, very explosive. So never use moisture, kids. We cannot use moisture now. Wurtz reaction is clear. Now, once the Wurtz has got so much publicity, another scientist came. His name was Fittig. Very fatty Fittig. Fittig said, "Hey, Wurtz, how are you, dude? I'm the Fittig. I will show you what I can do." What's my name? What he said? What is his name? His name, he said, "My name is Mr. Fittig." What is the name, kids? He said, I am Fittig. Who am I? Who am I? He said, I'm Mr. Fittig. See to me. I will show you something. I'm Mr. Fittig. Who am I? I'm Mr. Fittig. So Mr. Fittig has come. Oh ho ho. Fittig has come. Fittig. 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 Mr. Fittig has come. Hein? What is this fitting? Yeah. What's going on? Fittig. See, kids, what it is doing. He's not able to write Fittig. Hey, Baba. Not able to write Fittig. Don't write. Then I will write myself. Don't write. Fittig. Mr. Fittig. Always writing fitting. He said, hey, dude, what I'm going to use? I do the reaction with phenyl halide. I will use phenyl halide. It should not be X, should not be fluorine, should not be fluorine. That can be anything. Now he has used twice of Na dry ether. Same thing he has used dry ether. Now what is going to happen, kids? One phenyl, free radical, another phenyl, free radical will combine to give you the product. In this way, just see to it what product we will get, kids. The answer will be diphenyl. Diphenyl will be the answer. I can say diphenyl or biphenyl. Both are equally correct. Diphenyl or biphenyl. They are equally correct, kids. You got it? And twice of NaX. Twice of NaX. This is the mechanism I tried to show you. And twice of NaX is the product, kids. You got it? This is done by Fittig. Now, Fittig has become friend of Wurtz. Then they said, hey, come on, let's have party tonight. What was the name of party? They have kept the name, party's name. What name they have kept, kids? The party's name they have kept Wurtz-Fittig. What is the name of party, kids? They kept the name of the party. Let's have party tonight. The party's name they have kept Wurtz-Fittig. The party is extended. See here, the party will go on, kids. Just see. The party's name is what, kids? Do let me know what is the name of the party. The name of the party is Wurtz-Fittig party. Wurtz-Fittig. So Fittig, Wurtz-Fittig party. Now, Wurtz was using on its aliphatic halide like methyl chloride, and Fittig was using chlorobenzene. Now, what is going to happen, kids? Let's put twice of Na and dry ether. Dry ether, kids. Remain it dry. Otherwise, if you are taking moisture, explosion will take place. Bond बनाए. So bond is moving like this, my dear students. What you are going to get? Just to let me know. Toluene. The answer will be toluene. Toluene is the answer. Toluene plus twice of NaCl will eliminate out. This is the party Wurtz-Fittig reaction. Pow. There was one classmate. His name was Frank Land. He said, oh my God, these people are getting that much name and fame. He has come near to them and he said, hey, my name is Frank Land. Do you know, everyone, I'm being the Frank Land. Frank Land. Now Frank Land has come. He said, I will never use sodium. So what is using twice of Rx, he said, I'm having Jed and John. Jed and John. So Ra RR, Jed and X2. Jed and X2. And he got the product like this. Now, my dear, Frank Land. It's land. Frank Land. Frank Land has used Zn in place of sodium. He used Zn. Remember that Zn, right? Nothing. All they have prepared symmetrical alkane. They are preparing symmetrical alkane only. Now, there was one animal, bird, owl. Now the owl has seen, oh my God, what these people are doing. The owl has become man. Ullmann reaction. Ullmann reaction. What is the name, kids? Name is Ullmann. Ull has become man. Ullmann. Just see to it. What is the name? Ullmann reaction. Just see to it. Ullmann, kids. What's the name? What I'm saying? Ullmann. Ullmann. Ullmann reaction. Ullmann. What he has done, kids? He has used phenyl iodide. 2 moles of phenyl iodide, and he has used copper and some heat, and then he got diphenyl. Now, kids, till now everyone has prepared. Till now everyone has given method for preparation of symmetrical alkane only. Preparation of symmetrical alkane only. Now, kids, there was one scientist. His name was Corey House. Which house? Corey House. He said, I will give you the way to prepare symmetrical as well as unsymmetrical. Kids, are you ready for Corey House? Should I tell you Corey House, kids? Is everyone ready? Everyone, kids? Everyone, are you ready for the Corey House? One kid is saying out of NCERT. Who told you that everything will come from NCERT? This boy, Minecrafter, out of NCERT. Then you are not interested in getting rank or selection. Only 50 to 60% will come from the NCERT. He is a kid, very small kid. Now see, kids. Now Baba is going to tell you Corey House reaction. Are you ready for Corey House? Is everyone ready for Corey House? Corey House reaction. Which reaction, kids? Baba is going to tell you which reaction. Corey House. Corey House reaction, kids. Corey House. What is the name? Corey House reaction. Corey House reaction. What's special about this? This reaction is used for preparation of, both symmetrical. This is the first reaction for the first time for symmetrical as well as asymmetric alkanes can be prepared by this. Now let's see how to prepare, how to carry out this reaction. Just see, kids. Rx lithium iodide or lithium, it will convert into RLi. Just take 2 moles. Start with the 2 moles, 2 moles, 2 moles. Now use CuCl. It will convert into R2CuLi. Remember that this is known as Gilman's reagent. This is the reagent unsymmetrical. What is the name? Gill, like fish. Fishes, they are having gills. Gilman's reagent. You must have studied, you must know number of man, Spider-Man, Batman, number of men, but this is man who is inside the gill. Gilman's reagent. Gilman's, not reagents, reagent. Gilman's reagent. Now kids, the story begins from here, that if it is combining with R dash X, so what you will get? Rara R and R dash. This is unsymmetrical. And if it is reacting with Rx, rara, it is symmetrical. So in this way, it is used for the preparation of both symmetrical as well as unsymmetrical alkanes. Now preparation got completed. I could have completed this preparation just in 15 minutes, but I have covered up each and everything about the preparations. Now I will tell you chemical properties. It will not take too much time because chemical properties will not take too much time, but till now I have taught you the preparation which are given in NCERT. I have taken those 3 main parts which are given in NCERT and I have explained it. I have taken a number of things, each and everything, because they are going to be asked, because this time the paper will come on the tougher side. Now the preparation of alkane which are not given in NCERT, they are also there. I will not take too much time for them, but still I will take some time, because my duty is to give you 100%, my dear students, so that, okay, break. Yeah, but first let me complete the preparation. All the preparations I will take 10 minutes more, then I will give you break, okay? Just after 10 minutes I will give you one break. It's okay? Yeah, after the break I will start, but okay, right now you need break. Okay, so what's the time right now, kids? Right now it's 10:48. So 10:48. Nahi, abhi Kiran Pathak, I haven't taken anything. Now 10:48, 50. So 11:20. 11:20, okay? $11:20. Let's meet at 11:20, right, kids? Let's meet at 11:20, okay? With positive energy, will you come with? Everyone just to let me know. With positive energy, will you come, kids? Because only studious students are left. Rest of others I am not asking. We will do the chemical properties. And Baba will let you know some of the left preparations also. Some preparations which are not given in NCERT plus chemical properties. Okay, kids? but come with positive energy. Make a promise, kids. Everyone, you have to come with positive energy, kids. Make a promise. Okay, I have faith on you, kids. Welcome back, kids. Are you back, kids, with full on energy? Can you hear me? Can you see me, my dear students? Just to let me know. Your Baba is back. Yeah, in time. Just do let me know. Everyone can hear me, can see me. If yes, I want to see green hearts and fire. If you're ready, if I'm perfectly audible to each and everyone, for that I want to see green hearts. And if you're ready with full on Josh, I want to see some fire. Let's move here, let's move here, let's move here. That's really fantastic. So let's see, kids. Let's it go. Let's it go. Let's it go. Alkane. Our alkane is going on. We are dealing with alkanes. In our alkane, what we are dealing with, kids? In our alkane, the target is what? Target is right, the preparation. First, let me complete the preparation. In our alkane, we are dealing with alkane, kids. And in alkane, we are dealing with the preparation. I would like to say the preparation. So let me complete something more about the preparation. I would like to say, kids, it's missing in NCERT. This thing is missing in NCERT. Missing part of what, kids? Missing part of NCERT. Missing part of NCERT. So they are supposed to give in the NCERT, but they have not given. Let's see what's missing over there. So if I'm having any aldehyde or ketone, let us suppose this is aldehyde, or I can say this is ketone. If I say this is ketone, RC, where R can be hydrogen, it can be alkyl, or it can be aryl. Are you getting my point, kids? Aryl means aromatic. Now this is carbonyl group, so this can be either aldehyde or ketone, kids. It can be either aldehyde or ketone. Let us suppose either aldehyde, or I say it is ketone, right? Now they want to remove this carbonyl group. You want over there that we should get two hydrogens. That means aldehyde or ketone should get converted into alkane. Now what are the processes? My dear students, what are the processes? One process name is Wurtz-Fittig reduction. Remember that? Everyone say Wurtz-Fittig reduction. Wurtz-Fittig reduction. Kids, are you getting my point? Wurtz-Fittig reduction. What they are going to use over here? Hydrogen, NH2, KOH plus ethylene glycol. They will use ethylene glycol. Remember that this reaction is totally in basic medium. What is the medium? Over here, they are going to use the basic medium. This is the basic medium. Remember, that will play very, very important role. Basic medium is used over here, right, kids? Are you getting my point? Everyone, are you able to understand? Kids, let me see. Everyone? Yeah. Right, kids. Fantastic. And I can see you are full on Josh. That's something Baba likes. Now, my dear students, there is another method that is known as Clemenson's reduction. Either you can use Wurtz-Fittig reduction, or you can go with Clemenson's reduction. Now, my dear students, in Clemenson's reduction, the medium zinc amalgam and HCl. This is being acidic medium. Only the thing is that here the medium is acidic medium, kids. This is acidic medium. Now, my dear students, the third method which you can use, the third method is, yes, what's that, kids? That is HI red phosphorus. It is not having any name. HI red phosphorus. You can use HI red phosphorus, either of these, A, B, or C. And this is missing over there, so I have told you. Now, my dear students, one more thing, very, very important, that is used for preparation of alkanes. Let me tell you one more thing, kids, that is very, very important. Once again, let me tell you that is from Grignard reagent, kids. Preparation of alkanes from Grignard reagent. What I'm saying? From Grignard reagent. Have you ever heard the name Grignard reagent? Now, preparation of alkane from Grignard reagent. From Grignard reagent, kids. Grignard reagents. Grignard reagent. Grignard reagent, kids. Grignard reagent. Let's see. Preparation from Grignard reagent. Now, how to prepare from Grignard reagent? This is an organometallic compound, RMgX. Remember that this R is having negative charge. Everywhere it is acting as electron donating group. It is famous for donating electron, but in this Grignard reagent, it is going to withdraw. It is acting as -I group, and it is always searching for acidic H. And I will say not acidic, then active hydrogen. If it is getting active hydrogen, then R will take that hydrogen and it will get converted into hydrocarbons. So I would like to say that if you do the hydrolysis, HOH, H delta positive, it will accept this H plus, it will get converted into that, and the side product you will get magnesium hydroxy halide, MgOH(X), and this process is known as hydrolysis. Not present, then you can do alkolysis. It can even take hydrogen of that proton of this. These are the active hydrogens. So I will say Grignard reagent plus active hydrogens. Active hydrogen, if anyone is having active hydrogen, it will take. This is known as alkolysis, that is known as hydrolysis. Now, if ammonia, then ammonolysis, I would like to say ammonolysis. If 1 degree amine, then I would like to say aminolysis. If 2 degree amine, even they are having active hydrogen, then also aminolysis. So all they will give the same product, even if you are having acetylene, it is having active hydrogen, so it will take. If you are using phenol, then also you are going to get the same product, kids. I hope that everyone is able to understand. These things are missing in this chapter alkane, but they are very, very important for examination. I hope that everyone got it, kids. Now Baba is going to come with chemical properties. I am going to deal with the chemical properties, my dear students, which holds a hell lot of weightage. These chemical properties are very, very important. So let's go with the chemical properties. So let's start chemical properties, kids. Okay, so let's start chemical properties, kids. Are you ready, everyone, for the chemical properties? Show me some fire in the chat section if you're ready, kids, with full on Josh for the chemical properties. Yes, I want to see fire in the chat section that everyone is ready for chemical properties, kids. Everyone, kids, everyone. I will not take too much time. Don't worry, kids. Baba is not going to take too much time. Baba will try to complete it. No, kids, I haven't had my dinner. I will take it after the class. I will have it just after the class. I will try to bind it up. I'm just thinking that it's going to get over at 1, right? That's my opinion. Let's see the first chemical property. Kids, just see the first chemical property. So the first one is, I will go according to NCERT. Baba will try to move like NCERT, what is given, the sequence which is given in NCERT. I would like to follow that sequence, kids. Okay, let's see, kids. The first one, the chemical property, that is halogenation. I would like to deal with halogenation. Halogenation. What is this halogenation, kids? Now see, kids, let me tell you that if I take methane, remember that if I take methane, and this is not given in NCERT, even if I react with fluorine in dark, or if I react fluorine in sunlight, in both the cases, kids, it is going to form carbon black. Now this carbon black will be used for making ink, printer ink, right, kids? That is the use. It can be used over there, carbon black. But if I say that if I am going to react with the Cl2 and the darkness is there, no reaction is going to take place. No reaction will take place. But sunlight, then the reaction will take place. You will get methyl chloride. Once again the reaction will take place. We will get dichloromethane. Once again the reaction will take place. We will get chloroform. Once again the reaction will take place. We will get carbon tetrachloride. These 4 types of products we will get, and hydrogen chloride will keep on eliminating out as the side product. Hydrogen chloride will keep on remaining at side product, HCl. This will eliminate out. But if I react this methane with Cl2 at 12 noon means very high temperature, once again you will get carbon black. I hope that you are able to understand, my dear students. You got it, this first page? Everyone got it, this first page, kids? Do let me know. Now, let me go into the detailed mechanism of these things, because number of questions they will ask you about the mechanism, how the mechanism is taking place and how the products are getting formed. So, let me take, my dear students, this halogenation only. Let me write down the heading, because again and again we have to deal with this halogenation, kids, and again we have to deal with this halogenation. So let me write down here the halogenation, right? Let me write down here the halogenation, kids, right? What is this? Halogenation. So let me write down here halogenation. Right? Looking good, kids? Looking good? It's looking good. Nice. Because we have to deal with halogenation in detail. So let me write down here. No problem, kids, right? Now, halogenation. Remember that, my dear students. What's the important thing? Let me tell you that fluorine is like father. Chlorine is chlorine. Bromine is like bromine, and iodine at some places in Maharashtra, mother is known as I. They call mother as I. Now see, kids, in my childhood, I never used to go for shopping with father, because always he was scolding and he was saying, hey, just purchase this thing and that thing fast. Sometimes he was becoming explosive, difficult to be controlled. So, highly reactive, kids, highly reactive. This I'm telling about my father. I don't know about your father, right? Sometimes becoming highly reactive, sometimes explosive also, can't be controlled. So, we were never going for shopping along with father, and I was too slow. In my time, I was too slow, just searching number of shops, and at the last, my eye was saying, hey, we will purchase, we will buy it tomorrow. So, we were not going along with our eye also, no. So they will give you, my dear students, they will give you in examination the chlorination and the bromination. These are of use, kids. So chlorination and bromination. Out of chlorination and bromination, I would like to say this is highly reactive, or we can say more reactive and less selective. More reactive, less selective. What is the meaning of this, kids? And bromine is less reactive, more selective, kids. Now let's understand the meaning of this, kids, because this will play very, very important role. Very, very important role. When you are too much hungry, you must have eaten biryani, tomato biryani, chicken biryani, or whatever, samosa, better to say samosa. When you are too much hungry, you will dip inside the sauce and you will eat like this. But if you're not feeling too much, you're not starving, you're not feeling hungry, then either you will take its potato, or you will throw it out, or you will take crispy, that whatever the slices are there, or you'll say, what is there, coriander and tomato, and what is this? You will throw it out. Or let's take the example of what's that, sandwich. If you're feeling too much hungry, you will start from one side and you will end it up. Now if you're not feeling hungry, you will just put you try to throw out the outer part. It's hard. Oh, what the stuffing is there, you will do like that. Am I right, kids? Let me see what you're writing. Am I right or not, kids? Do let me know in the chat section. Oh, I will tell you what is endothermic or exothermic. Whatever I'm talking about, kids, you are getting my point. Kids, first of all, do let me know you are able to understand what I'm talking about, kids. Just to let me know whether it is making sense, kids. You show me the green hearts, kids, if you're getting what I'm talking about, what I'm trying to tell you, kids. You are getting it or not? Yeah, right. No, I eat it wholly. Oh my God, you are taking it personally. Oh my God. Okay, now see, kids, what is the meaning of this? Let me show you. Let me make one table. But before I make table for this, so let me tell you the mechanism, then I will make table for it. Okay, now see to it, kids. Now suppose if somebody has given you this reaction, my dear students, if somebody has given you this reaction, CH3 and Cl2. Now my dear students, one point to be noted very, very clearly. So if they are doing it photochemically, what? Photochemically, there is one word, photochemically. This reaction, if it is carried out photochemically, then what thing they will give you photochemically? And photochemically, they can give you either sunlight, or they can write down ultraviolet rays, or they can write down H nu. They will write down like this. This is photochemically sense. Now if they are going to deal with thermally, this reaction can also take place thermally, gets thermally. Then remember tofu C. What is this tofu C? TFC. What do you mean by tofu C? So the temperature will play very, very important role. T for 300 degrees Celsius, F for 500 degrees Celsius. This is Celsius, because in the examination you will forget about Celsius, because there is lot of confusion in the degree Celsius and Kelvin. If I write down, it is 573 Kelvin. So 773 Kelvin, because temperature matters a lot over here. Whatever they are giving, you have to do this reaction. You have to think about free radical mechanism. Just remember that. You have to think about what? Free radical mechanism, because no one will come to tell you this thing, that whether you have to think about ionic mechanism or you have to think about free radical mechanism. Is that clear? This is the hint. These two things are the hint that you have to think about free radical mechanism, because in the examination No one will come to tell you these things. Kids, are you getting my point? Everyone, these are the just, you can say, the signal that they are asking about. You are supposed to do free radical mechanism, kids. So remember that free radical, free radical, free radical, free radical. Now, free radical mechanism will take place in 3 steps. Free radical mechanism will take place in how many steps, kids? This mechanism will take place in 3 steps. 1, 2, and 3. 1, 2, and 3. What are these 3? I'm not going to tell you. But let me tell you, this is having 2 sub-steps. Sub-step A, sub-step B. Now, what are these 1, 2, 3? I'm not going to tell you. I'm not going to talk about 3. I'm not going to tell you chain initiation, chain propagation, chain termination. No, I'm not going to tell you. But this will take place in 2 sub-steps. Let's start. Let's move here. So, in the beaker, you can consider in the beaker there are what? There is ethane. Hey Baba, you are ethane. Yeah, I am ethane. There is Cl2. Now the sunlight will fall on this. I'm coming. I'm the sunlight. Morning, wake up. The sunlight will come over here. We are having number of types of bonds, sunlight, but this will break. So the first step is what? What is the name of first step of the mechanism? That is known as chain initiation. Everyone say chain initiation. What is going to happen? Free radicals are generated in this. Free radicals are generated in this step. Now see, this is having least electronegative difference. To form the free radical easily, the electronegative difference should be least electronegative difference. Better chances of free radical formation. Better chances of what, kids? Free radical formation, right? Now, Cl2 is non-polar, so it can easily form free radical. Now see how the free radical will get formed. Remember that this electron, fish hook arrow. This will take its 1 electron, fish hook arrow. What do we call it? Fish hook arrow. This is the representation, fish hook arrow. Homolysis, homolytic cleavage, homolysis. And this way we got 2 chlorine free radicals. So free radicals have come into this world. Kids, is it okay? In this way we got free radicals. Now what the free radicals will do? They will do in the chain propagation step. So this was the first step, chain initiation. Free radicals have come into this life. Now second step, chain propagation. What is the name? Name is chain propagation. Now in this chain propagation, that chlorine free radical will come to this compound. Hey dude, how are you? I'm going to break your bond. Hey, don't break it. Oh no, I will break it. Who is talking like this? The chlorine is talking like this. Now chlorine is thinking, with whom should I make a bond? With hydrogen or with the carbon? With whom should I make? Students, you tell me, whom? Hey, just see, buddy. If it is going to form with hydrogen, it will form like this. It is going to form with hydrogen or with this. Let's see, forming bond with this. So it will look like this, CH3, CH2, Cl. Then who will get free? Hydrogen free radical will get free. Now if it is going to form a bond with hydrogen, then who will get free? It will get free and it will form HCl. Now my dear students, remember that this is experimentally determined. If you see the bond energy, then HCl is more stable. If you see its bond energy, then this is more stable. It is found to be more stable. And if it is found to be more stable, that means its activation energy is less activation energy, and the one who is having less activation energy is favorable, and this path is not favorable. Its activation energy is very high, so it's very tough to cross that energy barrier, so that will not get formed, this will get formed, and here alkyl free radical is formed. Remember that in this step, this is sub step 1. This is being sub step 1 or A, sub step A. In this, alkyl free radical has been formed. This is alkyl free radical. Remember that. And alkyl free radical is an intermediate. It's an intermediate. So remember that rate of reaction is directly proportional. Rate of free radical reaction, rate of FRSR, free radical substitution reaction, is directly proportional to stability of free radical. And in free radical, shifting does not take place, but resonance may take place. Always think about resonance. Always think about resonance. Always think about resonance. So always think about resonance, kids. This is a sub step 1. Clear? If yes, till now it's clear, then show me green hearts. And kids, thank you that you are really studious students, because everyone has come, kids. I'm really, Baba love you, kids. Baba really love you. A lot of respect for you, kids, because just before the break, whatever the number of students were present, same number of students are present right now also. Really, kids, love, lot of respect and love for you, kids. Wow, Vignesh. So that's really fantastic. I'm really liking it. That's really awesome, kids. Really, it means a lot. It means a lot, kids. Really, really awesome. Really awesome. Really fantastic, kids. As soon as possible, I am going to complete this lecture, kids. Baba is with full on Josh, as I have seen that, kids. Really, really fantastic. Now see, really, really fantastic, kids. Wow, that's so awesome. Baba can see so many hearts. Baba is feeling like Shahrukh. Hey, fantastic. Now see, kids, chain initiation sub step A. Now let's deal with sub step B. Sub step B. Second, that chain initiation sub step B. Oh, chain propagation. What I have written, initiation, it was propagation. Chain propagation, yes, chain propagation. Sub step B. Let's see what is going to happen over here. One of the main product will get formed over here. One of the main product will get formed over here. See how and why. This free radical, there is no rearrangement, because It's already whatever it is, it's like this. So Cl free radical will come and will combine with this, so form CH3, CH2, Cl. So this has happened over here. Now the last step is known as chain termination. The third one is known as chain termination. Now whatever the one who has come into this life has to go. So almost all of the free radicals will get consumed. How they will get consumed? Let's see. Now just see. Look, if chlorine is extra, then chlorine will combine with chlorine. It will form Cl2 gas, right? Cl2 gas it will form. The second way, that if any ethyl free radical is left and chlorine free radical is left, once again they will form ethyl chloride, no problem at all. The main product once again over here. Now by chance, if ethyl and ethyl is left, only ethyl free radical is left, then what is going to happen, kids? Now there are two ways in which they can combine. One way, they can combine to form butane. This will be in traces, kids. This is going to happen in traces means in very, very small amount. Now it can undergo disproportionation. Number of times I am telling you disproportionation reaction, that the carbon is losing and carbon is gaining, so it will going to form CH2 double bond CH2 and plus ethane. This is also in traces. So ethylene gas is used for artificial ripening of fruits. Done and dusted, kids. Done and dusted. Really, it's awesome, my dear friends. Got it? Till now it's clear. Now, what I was going to tell you, that this one, kids, let's focus on this one. Just see. I was going to tell you about this reaction, this thing. So let me take it. Let me bring it over here. Now, I was talking about this, that chlorine is more reactive than bromine. Now, let me make that table which is experimentally determined, and number of questions will come from here. This is the table I am going to make, that is experimentally determined. Just see. What's that? So one is for chlorine and one for bromine. So this is for chlorine and this is for bromine. I am going to write what I am going to write. Just see and focus over here. That reactivity, comparative or relative reactivity for 1 degree hydrogen and 2 degree. 1 degree hydrogen, 2 degree hydrogen, 3 degree hydrogen. Now let me tell you first of all the stability of free radicals, because you have not studied GOC. Once you have not studied GOC, so it's my duty, because you kids are really devoted, studious students. Let me tell you that who is most stable. Remember that 3 degree free radical is most stable. Who is most stable? 3 degree. How to find out 3 degree? That the carbon having free radical attached with 3 more carbons. This is maximum stable. Then the number comes for 2 degree free radical. 2 degree free radical is stable, kids. And then the number comes for 1 degree free radical. 1 degree free radical is stable. And then methyl free radical is stable. So kids, definitely this must have formed by removing of hydrogen. It must be remaining. Before removal of hydrogen, it must be what? It would have been the alkane only. Once we have removed their hydrogens, then they have become free radicals, right? So this is the stability order. Now definitely 1 degree, then 2 degree, then 3 degree. Most easiest is to remove 3 degree hydrogen because 3 degree free radical is more stable. But experimental data, what they have got, the experimentally determined table. This is experimentally determined, right? Now this is 1, this is 3.8, cram it, you have to cram it, and this is 5 times more. That chlorine's reactivity for 1 degree hydrogen removal for 1 degree carbon, because hydrogen is removed, the chlorine will love carbon, 1, 3.8, 5 times. But see bromine, 1, 82 times more and 1600 times more. So much selective. Can you see the selectivity of bromine? It's highly selective. It's highly reactive, not that much selective. See, this is reactive more, less selective. This is selective more, kids. Right now, if you are not able to understand what is the meaning of reactive and selective, I am going to give you example, then it will get clear. Kids, are you ready? Are you ready? Let me show you this thing in detail. Suppose if I have taken one example, just see, if I have taken one example, kids, see, suppose if I am having this propane, suppose if I take example of propane, now tell me how many 1 degree hydrogens are there and how many 2 degree hydrogens are there. You will say, sir, this carbon is attached with 1 carbon, so this is 1 degree carbon, and that is also 1 degree carbon, and this carbon is attached with 2 more carbons this side and that side, so this is 2 degree carbon. So how many hydrogens? 3 1 degree hydrogens and 3 1 degree hydrogens. Can you see? 3 plus 3, I am having 6 primary hydrogens. Primary means 1 degree hydrogens. Clear? Is it clear, kids? I can say primary or 1 degree. Now I am having 2 secondary hydrogens. Till now it is clear, kids? Till now is it clear, kids? Do let me know. Is it clear till now? Clear? Now if I do the chlorination of this compound, if I do the chlorination of this compound, let's see, once I will do chlorination and second time I will do bromination. Just see, kids. Once I will do chlorination, second time I will do bromination. So if I add Cl2H nu, I will get 2 types of product, CH3, 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 CH2, CH2, Cl over here, Cl at this place. Now which is going to be major, which one is going to be minor, that we can directly see which is going to be major and which one is going to be minor, because it is attached to secondary, so definitely it is going to be major and that is going to be minor. But the problem arises when they are going to ask percentage, that this is X and that is Y. Now find out the percentage of X. Now that is really going to be a challenging question. Now see, kids, how to do this question, how to find out the percentage. Just see. Here you can see the chlorine is attached to 2 degree carbon, 2 degree carbon. And 2 degree hydrogens we are having 2. So 2 in the reactant, always see in the reactant, don't see in the product 2 degree hydrogen, because this has converted into that. So 2 degree hydrogens we are having 2, and the reactivity for 2 degree hydrogens, how much we are having reactivity, just see how much reactivity we are having for 2 degree. 3.8. Chlorine reactivity for 2 degree hydrogen is 3.8. So multiply by 3.8. Now the same thing you have to write down in the denominator, and plus you have to write down something. What plus you have to write down? That this is having 1 degree hydrogen also, 6 primary hydrogens we are having 6. So 6 into reactivity for primary hydrogens is 1, and now multiply by 100. Multiply by 100. Only this much you are supposed to do. First of all, do let me know whatever I have written you are able to understand or not. Whatever I have written. Sahana, good morning. Oh my god, 12. It's 12. Wow. Now kids, do let me know whatever I have written on the numerator side and denominator side. Is it clear to all of you kids? Do let me know first of all. If not clear, I will tell you once again kids. Rainy, Vritika, Dr. Tanu, Nitesh, Varan, kids, everyone, just do let me know. Avira, Madhumita, Jyoti Jain, good morning. Calm Mind, good morning. Kids, do let me know, is it clear whatever I have written in the numerator and denominator? Srinath, good morning. Niranjan Pillai, wow. Kids, everyone, just to let me know this much is clear whatever I have written in the numerator and denominator. If not clear, I will explain once again, don't worry. Wasim sir is there. Really? Really Wasim sir is there? Yarya, may Almighty God bless you with all happiness and prosperity. May Almighty God give you the best life and the best rank. Really Wasim sir is here? Really kids? Hey bro, are you there? Oh yeah, Baba. Pucho kyun? Oh ho, Wasim bro is there kids. Wasim bro is there. Wow. Hi. Kaisan Bab, bro, how are you? How are you, bro? Hey. Thalaiba Wasim is there, kids. Yes, Baba. Okay. Now kids are so happy. Wasim bro, kids are super duper happy. Nalla Eriku. Wow, Nalla Eriku. The chemistry was looking idiyappam. For these kids, the chemistry was looking idiyappam, Murku. Now it has become Romba Sulvam, Nalla Eriku, Arpudham. The starting everyone says that chemistry pedigaradu customer, but it's Romba Sulvam. Only it will get completed at 1. So 1 more hour. Just 1 more hour. Just 1 more hour. बस 1 बजे कंप्लीट हो जाएगा. वसीम ब्रो 1 बजे कंप्लीट हो जाएगा. It will get completed at 1 a.m. Okay. Okay, thank you, bro. Thank you. So everyone say bye to sir by showing fire or green hearts or mixed. Fire and green hearts or mixed. Say everyone good night to sir. Kids, wow, great. I can see. This is really so awesome, so awesome. It's looking marvelous. It's looking marvelous. See, Basim Bhai, kids, love, respect for you. Wow, see, Basim Bhai. Wow, wow, they made Diwali. So awesome, kids. Really awesome. I liked it. Really awesome. Really awesome, kids. Wow, fantastic. Okay, kids. Let's go. Okay, let's see and let's calculate the percentage over here. Okay, so let's calculate the percentage. Who is going to tell me what percentage is going to come? 3.8, 8 to the 16, 3 to the 6, and 1, 7, 7.6. 7.6 upon the 7.6 and 6. There are 13.6. 13.6 into 100. Now see, 14 means 55% approximately I am getting over here. Kids, do let me know. Use the calculator and do let me know what answer you are getting, kids. Do let me know. With my calculation, I am getting somewhat 55%. You just do let me know. I want to see in the chat section how much you are getting. How much you are getting, kids. Do let me know. Do let me know. Use your calculator and do let me know. 55. Oh my God, it's coming 55%. So one is coming out to be 55%. Then definitely the another one we can calculate. It should be 55. So it will be how much? 45%. It must be 45%. Now it's clear. This is 45 and this is going to be 55%. But if you see the same thing in bromination, then see what you are going to get. Just see to it. If we do the bromination of the same compound Br2H nu, kids, Br2H nu, we will get CH3 CH Br CH3 plus CH3 CH2 CH2Br. We will get this compound. Now the percentage of, let's say this is A and that is B. Now let's find out here the percentage of A. You have to help me, kids. You have to help me. I will draw one line, the numerator and the denominator. This is the line, above it numerator. Now see, 2 degree hydrogen 2 and this is at 2 degree hydrogen, and 2 into I will multiply by 82. Why I have multiplied by 82? See, the relative reaction for 2 degree, this Br2 for this was 82, 2 degree hydrogen 82. That's why I multiplied with 82. Oh my God, 82. Now I will write here 2 into 82, and then what I will write, kids, what I am supposed to write, 2 into 82 plus 6 into 1 into 100. Now how much I will get? Yeah, 6. So 164 and 6. 164 and downside 164 and 6. 170. Now see, kids, how much you are getting. If you are active, then do let me know. It will be more than 95% or 90%. Just to let me know. Use the calculator. Use the calculator, kids. Wow, very good, kids. You are very good person also, along with the good strengths, good heart, and good fantastic kids. That somebody's birthday, one kid's birthday, you are celebrating. That's really so awesome, kids. But do let me know the percentage. Now 96% means it's highly selective. It is highly selective for this. This 96% means that it is highly selective. Am I right, kids? So I have told you that it is highly selective. Highly selective. Now, kids, let me give you one very, very awesome example where even teachers are getting failed. Let me give you that example where teachers get failed. Let me show you that example. See kids, if I give you this question, CH3, 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 what do you call it? This is, yes, isobutane. Now isobutane is having two types of hydrogens. This is primary carbon, this is primary carbon, this is primary carbon, and this is tertiary carbon. So primary hydrogens I am having how many? 3, 3, 3. 3 plus 3 plus 3, total 9. And tertiary hydrogen I am having 1. Now if I say kids that if I do the chlorination, I will get two types of compounds. Definitely I am going to get two types of compounds. What are these two types of compounds? One, I will get CH2, CH, CH3, CH3 plus CH3, C, CH3, CH3, and this one. I will place here chlorine. I will place there chlorine. Let me call it M and let me call it N. What do you think which is going to be the major, M or N? Do let me know. Which is going to be the major, M or N? My question is, kids, write down in the answer in the chat. Who is going to be the major one, M or N? Do let me know. M or N, kids, do let me know. Who is going to be major? Who is going to be major? Generally, we ask this question for training faculty, those who are going to give their written. So everyone is going for M. But kids, let me tell you who is major. The major one is M. This is major one, and this is the fantastic thing, kids. It's the major one. It's major. Now it's a shocking or not? When everyone is going for that, that is the major, but this is the major. Shocked or not? Shocked or not? Yes. Now see why this is major. Let's calculate the percentage of M. Let me draw this line and just start calculating. This is known as unity is a strength. Unity is more powerful. Now see, we are having primary hydrogens 9. If you calculate 9 into 1 upon 9 into 1 plus tertiary is 1, 1 into 3 into 100, into 100, just see what will come, kids. 9 divided by 9 plus 3, 12 into 100. How much it will come out, kids? Do let me know. How much it will come out? Tell me how much it will come out, kids. 900 upon 12. How much it will come out? Tell me, kids, how much? Tell me the percentage. You got trapped. This is a trapped question. 72, 72, 84, 84, 84. Means more than 70%. So 75% you are getting. How much you are getting? 75%. You got trapped or not, kids? So that's why this is really awesome. This is really awesome. This is really awesome. See, 3 degree hydrogen, 1 degree hydrogen, we are having 3 plus 3 plus 3, 9. We got 9, kids. We got 9. So 9 into 1 and 9 plus only we got, no, this is, sorry, I have done wrong calculation. So this 1 should be multiplied by 5. I have done wrong calculation, kids. This 1 should be multiplied by 5. Why it should be multiplied by 5, kids? Because its reactivity was how much? See, it was 5, kids. It is 5, okay? It is 5. Got it? Correction to be needed, 5. So I have to write down 1 into 5. Then how much I will get? See, 9 upon how much? 14 into 100. Now do, kids, because a little bit more it was coming. I was shocked. how it is coming more than 70%, not 70%. There was one correction required, kids. Do let me know. It's coming how much? 14, 14, 14, 84, so it's coming out 60%. It's coming out 60%, right? Approximately 60%. But then also it is more. That is going to be major. That's the correct answer. Got it, kids? This is done and dusted. Done and dusted. So I can move ahead, kids. If it is done and dusted, now the second property is combustion. After halogenation, we will move towards combustion. Kids, are you getting it? Everyone, are you getting it? But before moving towards combustion, one question based on halogenation. Let's see. If they are asking very brilliant question, kids. Most frequently asked question, that how many types of chlorinated products will be obtained in the following reaction. Reaction is this one, CH3, CH3, Cl2, H nu. Tell me, kids. I'm waiting for your answer. Before I give answer, I would like to see in the chat section. I would like to see in the chat section. Yes, kids. I'm waiting for your answer. Everyone. Baba is waiting for your answer, kids. Herobrine is going for 1. Vignesh Pillai. Most students are going for 1. Kids, why are you going for 1? Kids, how many types of chlorinated products? It's not monochlorinated, kids. How many types of chlorinated? It's not monochlorinated, it's chlorinated. It's chlorinated, kids. It's not monochlorinated. It's chlorinated, kids. No one is correct. No one is correct. Just see. Just see. We got 3. Three more we got. Three more we got. How many are these total? Just check if anyone repeated. I don't think anyone repeated, kids. So the answer is 9, kids. Answer is being 9. I hope that you got it. Answer is 9, kids. Is it clear? Got it? Answer is 9. Just to let me know in the chat section. Its answer is 9. You got it, kids. Everyone clear? Is it clear, kids? Do let me know. Everyone do let me know. And hit the like button, kids. Make it at least 400. Everyone, those who are not, smash the like button. Smash it right now. Kids, really good question. Really good question. Everyone got it. If it is really you're liking it. 9. Yes. This was really nice question. Really nice. Now, kids, after this, let's see the second chemical property, that is combustion. I would like to say that is combustion. You know very well this chemical property, that combustion, well-known chemical property. Everyone knows that what is going to happen on combustion. Let's see the combustion. That any compound, if you take, that let us suppose if I have taken C2H6, and if you are going to react with excess of oxygen, remember that oxygen should be in excess, then what will you get? Carbon dioxide and water plus lot of amount of energy you are going to get. Now, how to balance the reaction? That is the question, that how to balance the reaction, kids. How to balance the reaction, okay? Now, how to balance, just see. 2 carbons. Always remember that CHO. First carbon, then hydrogen, then oxygen. The balancing order is like this. Carbon is 2, so multiply by 2. Hydrogen is 6, so multiply by 3. Now you can see how many oxygen? 2, 2 is 4, and 3, 7 oxygen. So 7 by 2, because 2 and 2 cancel out, 7 by 2. Any hydrocarbon you can balance easily. For example, if somebody has given you butane, C4H10, now you know that reacted with O2, then you will get carbon dioxide, then you will get water, a lot of energy you are going to get. Once again, the fundamental thing is same. What is supposed to do? 4 carbons, so multiply by 4, and 10 hydrogens, so multiply by 5. 4 2s are 8, and 5 13, so 13 by 2 O2 gas, right? This is the way you can do. Now, if they are not going to do combustion, if they are going to deal with controlled oxidation, that is very, very important, kids. What I am talking about, controlled oxidation. This will play very, very important role, and kids, with this we have to understand controlled oxidation, kids. What I am saying, controlled oxidation. If they are going to deal with controlled oxidation, then what we will get? Controlled oxidation. Controlled oxidation, kids. Controlled oxidation, kids. Now, number of times everyone is getting trapped in this controlled oxidation, kids. It is given in NCERT, but no one is going to give focus, no one is going to give importance for controlled oxidation, and it holds a hell lot of weightage. Come on, man, chuck the taste. The trick is, come on, man. For this, what is the trick, kids? First, let me write down, come on, man, chuck the taste. What is come on, man, chuck the taste? Now, what is this trick? Let me tell you. Suppose, kids, I'm provided with ethane. Just see, if I'm provided with ethane, and if I'm doing controlled oxidation in presence of copper and heat, I will get whatever the number of carbon, same carbon, alcohol, I will get alcohol. Same carbon, alcohol I will get. Now, come on, molybdenum oxide, if I am using MO2O3 plus heat, I will get aldehyde, because after this, the more oxidation state is of aldehyde with same carbon. Carbon will not get changed, kids. Carbon will remain same. Now I am using, come on man, check the taste, man, the taste, acetate, CH3COO whole twice manganese plus heat, I will get acid. I will get acid with same number of carbon atoms, kids. This is very, very important. But one thing is more, that only one alkane. Which alkane? CH3. This is very, very special reaction. Very, very special reaction. Very, very special reaction, kids. What's that? This reaction that it is going to react with KMNO4. What is the color of KMNO4? You know, kids. KMNO4. PPR, purple, pink, red, potassium permanganate. Either you can say pink colored, purple colored, or red colored. Potassium permanganate, you will get alcohol of this. So the compound will be alcohol. This happens with only this alkane. This reaction is not common reaction, will not take place with others. Controlled oxidation, kids. See, alcohol, aldehyde, acid. If I talk about oxidation state, their oxidation state is increasing. So it's very easy to remember this way. This way it's very easy to remember, kids, from alcohol to acid. You got it, kids? First of all, do let me know the controlled oxidation is clear. Is it clear, kids? Do let me know. First of all, everyone. Do let me know, is it clear, kids? Controlled oxidation. Everyone, do let me know, kids. Controlled oxidation is clear to all of you or not? Hey, everyone. Where are you? P. Lakshmi. Very good. Virtika. Minecrafter. Very good. Fantastic. Fantastic. Now, I will take only 20 minutes, kids, then it is going to get completed. Just 20 minutes more, not more than that, not more than that, kids. Maximum 20 minutes. Fantastic, fantastic, kids, fantastic. Before, clear, wow. Now, okay, let me write down the trick. Let me write down the trick. Come on, man. The trick is come on, man, check the taste, come on, man, have the taste, check the taste, taste means acetate, come on, man, check the taste, CuMO, man, acetate, right? Now, let me tell you, kids, now the very, very important thing, aromatization. Aromatization, are you ready for that? Aromatization. This is also very, very important, aromatization. Now, kids, suppose if I take N-hexane, normal hexane, and if I react it with what? The elements, oxides, they play very, very important role. The trick is for these elements, the trick is Okay, I will tell you the trick first, right? Let me write down the names. Cr2O3 or MO2O3 or V2O5. Then I will get benzene. Now, what is the trick for this? Because trick is required, otherwise you will forget. Trick to remember is movie of 1 crore. Aroma movie of 1 crore. Aroma means aromatic. Aromatization. Aroma movie of 1 crore. Right? How is that trick? Aroma movie. 1 CR, crore, rupees, movie, crore. So, MO for molybdenum, V for vanadium, crore is for chromium. Right, kids? Is it okay? Now, if you have used in place of N-hexane, if you have used N-heptane, that is a question given in NCERT. N-heptane, if this would have been given, then you must have got toluene. Toluene should be the answer, kids. Toluene would have been the answer. Got it? Got it? Got it? Everyone is getting? Kids, do let me know. Only 10 to 15 minutes. Not more than that, kids. Not more than that. Aroma movie, crore. Yes. Aroma movie, crore. Kids, you are not smashing the like button, kids. What are you doing? Hit the like button. It's 393. Make it 400, kids. Madhumita, you are liking it. Kids, you are liking it. Thank you. Aroma movie, crore. Now, kids. Now, let me tell you. Physical properties, I will tell you. Don't worry. I will tell you. This is okay. This is done. Now, let me tell you the pyrolysis. Next one is pyrolysis, kids. Pyrolysis. What do you mean by pyrolysis, kids? First of all, the breaking of higher chains into smaller ones when very high temperature, or you can say when temperature more than 2 C, that was 2 TFC, 300 to 500 degrees Celsius, but here FSC, that was TFC, this is FSC. What do you mean by FSC? 500 to 700 degrees Celsius. That means I can say 773 Kelvin to 973 Kelvin. This much of temperature is required. Then the breaking of, this is also known as cracking. Pyrolysis, or you can say cracking. Cracking starts with C. Cracking, kids. It is also known as cracking. Now, how the question will come, kids, on this? The question will be asked on nitration. Number of times they have asked question on nitration with taking pyrolysis as the example. Just see nitration. What question they have given in the exam? Let me give you the same question. Nitration. They asked that if we do the nitration of butane, then what will happen? First of all, the nitration will not take place at normal temperature. Under normal conditions, no reaction. No reaction. But if you give temperature, how much gets? Nitration, if you carry out nitration at what temperature? I have told you FSC. FSC means how much? 500 to 700 degrees Celsius. Then reaction will take place. Now what is going to happen? See kids, this alkane will remove its hydrogen. The primary hydrogen it will remove. If primary hydrogen has gone, it will form this free radical. If secondary hydrogen has gone, it will form this free radical. If it is going to break from here, it will form this free radicals, 2 moles of this. Now out of these A, B and C, A, B and C, which is looking to be most stable? Definitely the free radical. This one is looking to be most stable because this is 2 degree, that is 1 degree, this is 2 degree. So this is most stable, my dear students. Now who is going to add up over here? That is the $1 million question. Now for that we have to see over here who is going to add, because the temperature has broken down that alkane, so temperature is going to break this HNO3 also. Now HNO3 will break like this, NO2OH, it will break as free radical from here. Now there we got NO2 free radical plus OH free radical. Now electronegativity of carbon, sp3 hybridized carbon is 2.5 and electronegativity of nitrogen is 3 and electronegativity of oxygen is 3.5. The bond of equality is good. So who is more closer to the carbon? Definitely nitrogen is more closer to the carbon. So it will react with NO2 also, it will react with OH also, but this product is going to be most stable. It will react with OH also, NO2 also. So the most maximum, the major amount or the major product they have asked, during this reaction they have asked the major product. So the major product will be CH3, CH2, CH, NO2. This one is your major product and this one they have asked. Rest of others like alcohol, we will get alcohol also. All these are going to be the minor product. They will be the minor product. It will also react with OH. It is also going to react with NO2 and OH, but they are going to be the minor products, kids. They are going to be what? The minor products. They will be the minor products. I hope that everyone, that this one also going to react with NO2 and OH. So you will get CH3, CH2, 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 NO2, and you will get with OH, CH3, CH2, 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 OH, you will get OH. This thing is clear? Show me. Now I will take maximum 7 to 8 minutes. 7 to 8 minutes. I will take just 7 to 8 minutes. Kids, to let me know this much is clear to all of you kids. Everyone, this much is clear. Baba is completing each and everything, kids. Baba is not going to leave even a single thing, but Baba is telling you each and everything in detail along with each and everything, kids. Do let me know, is this much clear, kids? So that I can know 400 likes. Thank you, kids. Everyone, do let me know till now this is clear or not, kids. Do let me know, everyone. Fast, fast, fast. Reaction with the steam. I will tell you reaction with the steam and the isomerization also. I am going to tell you the isomerization also. Kids, let me have a water, one glass of water. So Baba will let you know each and everything, kids. Do let me know that you are able to understand or not, kids. First of all, do let me know everyone is able to understand or not, kids. Do let me know, kids. Fast, 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 kids. Kids, fast. Very good, Stella. Now, isomerization reaction, isomerization. So let us suppose if I take N-hexane and if I reuse anhydrous AlCl3, then remember that whatever is given, branching will take place. That's all, branching. So 6 carbons, what you can do? You can take one branch and take chain of 5 carbons. That's it. Plus you can put carbon over here, CH2, CH3, 5 carbon, 3 to 5, 6. You can make like this, CH3, CH3, CH3 and CH3, 1, 2, 3, 4, 5, one more carbon. That's it, etc. Right? Simple. Now last reaction, but after that I will tell you physical properties and one memory chart. So within 7 minutes I am going to complete this. Physical properties and then one memory chart. Okay? 7 minutes only. Now the reaction with the steam. Reaction with what? Steam. Now see, if I take CH4 plus water, what do you think what you will get? What you will get, kids? Do let me know what you are going to get. CO plus what is left? CO, and only the thing will left will be the hydrogen gas. Right, kids? So it's so simple. Okay, my dear students, you got it. One reaction in the preparation is left. That I will tell you in the means what? That I will tell you in what? That I will tell you in this memory chart. So Baba is going to give you the memory chart. Just see the memory chart. Everyone just see. This is going to be $1 million. Otherwise you have to make a payment for this. But Baba is going to give you for free. Just see. If I say that I am provided with the benzene, I am provided with benzene, and if I react this benzene with methyl chloride, anhydrous AlCl3, what I will get? I will get toluene. Now the picture comes from here into the roll. This toluene, if I do chlorination, right now I have told you chlorination H nu, I will get benzyl chloride. What I will get? Kids, I will get benzyl chloride. Now once again FRSR, I will get benzyl chloride. Now again FrSr, I will get benzo trichloride. Benzo trichloride. Now my dear students, 3 times FrSr I have used, 3 times. This is free radical substitution reaction. This is Cl2H free radical substitution reaction. This is Cl2H free radical substitution reaction. Its name, remember that, its name is toluene. This was Friedel-Crafts alkylation. FrSr, its name is benzyl chloride. Remember that, benzyl chloride. Everyone say benzyl chloride. Benzyl chloride. Benzo trichloride. Benzo trichloride. Now this is showing reverse hyperconjugation. So if I react this with Cl2 anhydrous AlCl3, then that is meta director. So I will get product over here like this, CCl3 and chlorine at this place. Now my dear students, if I react this compound with hydrogen Zn HCl, this was also given in NCERT. Remember that, then the all chlorines will go away and you will get back hydrogens, and people will start thinking that how you got it, because this reaction is very, very important. Let me show you at this place what reaction is given in NCERT. That the reaction given in NCERT is like RCl, and if you react it with H2 Zn HCl, you will get RH. This is also one preparation of alkane kits. If you're really liking it, do let me know. Now Baba is going to take just 5 minutes kits to tell you the physical properties kits. Till now it is clear, you got it kits. How is the memory chart kits? You're liking it kits? Do let me know. Everyone, Sahana is there kits, really thank you. But do let me know everyone is able to get it or not. This memory chart, you are getting it or not kids? Do let me know. Everyone is able to understand the names benzyl, benzyl, benzo, benzyl, benzyl, benzo. Everyone is getting it or not kids? Wow, Madhumita is there, Niranjan Pillai is there, Prama, loving it, wow, wow, Sausi, very good, very good, very good, everyone, this is really fantastic, looking fantastic. Now, so now these things are clear. Now let me tell you, my dear students, remember that one thing. Let's come to the physical properties. Now, in place of chemical, this is the last topic. It will take just 3 to 4 minutes, not more than that, kids. Just 3 to 4 minutes. Are you ready? Go away, go away, go away. Physical properties are going to take your place. Hey, hey, hey. Hey, 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 hey. Okay. Okay. Now, which color should I use for writing physical properties? The redum red. Okay. I'm going to use this color. Physical properties, physical properties. physical properties. Okay, now see kids, remember that boiling point is directly proportional to molecular mass. Now, if the molecular weight is fixed, in case if the molecular mass is fixed, then boiling point is inversely proportional to number of branches, but this is valid only for isomers, because isomers have same molecular mass, same molar mass, so branches. Or you can say that van der Waals forces of attraction, van der Waals forces of attraction is directly proportional to straight chain compounds. Why straight chain compounds? Because straight chain compounds, they occupy more surface area. Straight chain compounds, they occupy more surface area. Straight chain compounds have more surface area. Straight chain compounds have more surface area, and more surface area means more van der Waals forces of attraction. Now see kids, if I say in the light of this, if I say kids, okay, once again then I have to write down here physical properties kids. Oh my god. Now see kids, it's not looking good. All right. Okay. Now see, if I say methane, more than methane, the boiling point will be of ethane, and more than this ethane, the boiling point is of propane. More than this, the boiling point of butane. Now in butane, if I say that two types of butanes we are having, one is isobutane, one is normal butane. Who will have more kids? Who will have more? Boiling point of which butane will be more? Do let me know which butane will have more boiling point kids. So definitely the answer comes that isobutane will have less boiling point, and N-butane will have more boiling point because it is straight chain. So it will occupy more surface area. So definitely it will be like this only kids. Am I right? Now, if I talk about pentane. Now pentane, all these are gases kids. First of all, let me tell you, this is being gas, this is being gas, this is being gas, this is being gas. They all are being gases kids. Now if I talk about C5H12, if I talk about C5H12 kids, so definitely I will say how it will move. Like this is having maximum branches, this is being neopentane, this is being gas kids. This is the only gas. If I talk about rest of others, they are liquid. Isopentane, this is liquid. If I talk about N-pentane, that is also liquid kits, and their boiling point will be in this order kits. I hope that everyone got it. Now only the melting point is left. These are liquids. This is also being liquid kits, and the boiling point order is like this. I hope that this thing is clear, kids. Do let me know. Let me have a glass of water, kids. Now, kids, do let me know. You got it till now. Only the melting point I have to tell you, kids. Only 2 minutes more. Kids, do let me know you got it or not. Hema Shah, your doubt is genuine doubt that what about conformational? I will teach you one day about conformational isomerism. Don't worry. One day I will keep one session for conformational also, so don't worry. Okay, now let me tell you the melting point. Just last 1 minute. Melting point. Melting point. Are you ready, kids, for the melting point? Now see, kids, definitely even melting point will increase with the increase in molecular mass, but if I draw alkane, just see the alkane. If I draw one alkane like this, one alkane is given like this, and I am going to draw another alkane like this. How many carbons in this and how many carbons in that? Just see, kids. This is having 1, 2, 3, 4, 5 carbon, odd number of carbon, and this is having 1, 2, 3, 4, 5, 6, even number of carbons. Now whose crystal lattice packing is better? One thing is, with the increase in molecular mass, melting point will increase, that it is directly proportional to molecular mass, undoubtedly, kids. But this also depends on better crystal lattice. Its crystal lattice will have better packing. It will have better crystal lattice packing, better crystal lattice packing, so its melting point will be more. So more melting point, kids, more melting point, it will have more melting point. And this just you can compare with the adjacent members, not with the higher, only one carbon difference. Compare with only one carbon difference, only one carbon difference. So it is having odd number, that is having even number. This crystal lattice packing is not that much good. Crystal lattice packing is not good. Kids, this is all about I hope that everyone is able to understand, kids. Do let me know, is it clear, kids? It is done and dusted. Everyone, just to let me know what I said. It will get completed near about 1. So it got completed at 1 only, kids. Over and out, done and dusted, kids. Done and dusted. Do let me know, kids. Bye to all of you, kids. Bye bye. Good night. Shivratri, Shabba Khair. ధన్యవాదాలు. నమస్కారం. Sayonara. Let me see your chats. Wow, kids. Thank you, Raki, Bhumika, Rizwan, Madhumita, perfecto, good night. Yaraya, happy birthday. Bobby, Sahana, Sausi. Kids, you are really Baba's oxygen. Sausi, Kirti, M. Srinath, Madhumita, you are Baba's oxygen, kids. Jayashri, Mahalakshmi, Haniroof, Rohini, M. Srinath, Priya, Yepri, Jayashri, Vikash, Namita, Sahana, Shaira Saxena, Monica Priyadarshini, Niranjan Pillai. Kids, I remember your name. Hans, Preeta, Praveen, Vartika, Tanu, Shaira, Sahana. Have something. Yeah, definitely. Sahana, I will have dinner after this. Just as soon as I reach my home, I will have dinner. Definitely, I will take dinner. Stella, thank you. Good night. P. Lakshmi, thank you. Nitish, Warren, Nitish, yeah, thank you. Vidhi Yadav, thank you. Raki, yes, definitely. Kids, really love you, kids. Bye to all of you. Good night, kids. Good night. Bye, kids. Bye to all of you, kids. May Almighty God bless you, kids. Love you, kids. Almighty God give you the best life, best rank, kids. Bye to all of you, kids. Good night. Wow, Sausi, wow, great. Kids, calm mind, Rakib. No, not in home. I am taking this class from the office. This class Baba is taking from office, kids. Rakib Rauf, Hasini, Bharat Verma, Dr. Shri, SPA, thank you, kids. Bye to all of you. Bye, kids. Bye, kids. Bye. Nitesh, Varan, thank you, kids. Reach home safely. Sahana, thank you. Sure, Hasni. Okay, kids. Stella, bye, kids. Rani Upri, thank you. Okay, Avinya, thank you.